Hello everyone, this is Durga from IT University. Welcome back to our channel. In this full course, you will be understanding how to build pipelines using Python and Copilot. We'll be building end-to-end pipelines where we'll get the data from source using REST APIs, then process using Pandas, then store the processed data into MongoDB using PyMongo. You will understand how to build applications quickly using Copilot. What is Copilot and how it can help, you will understand very soon. But first, let me go to the prerequisites and then I'll take it forward. When it comes to prerequisites, you need to have Python installed on your machine. Along with Python, it is better to have IDE. IDE stands for Integrated Development Environment. The popular IDEs are nothing but VS Code and PyCharm. I'll be demonstrating using VS Code, but if you are already a pro with PyCharm, you should be able to use PyCharm also without any issues. If you are a beginner, I'll recommend VS Code. In case if you are not sure about how to install Python and also how to install VS Code and then integrate them, don't worry too much about it. Look at the description of the video. You will see a link. If you go through that link, you will get all the details with respect to not only installing Python and VS Code, but also integrating them. It is required to have proper IDE along with Python to take this course effectively. That being said, if you are first timer to our channel, if you are not subscribed yet, feel free to subscribe the channel and also hit on bell icon so that you can see this kind of content whenever we upload. If you like the course at any point in time, make sure to like, comment and also share with your friends. Now, without wasting any time, it's time for us to explore how to build end-to-end pipelines. Let's get started with setting up the project and then we'll take it forward. First, let us go through the dataset which we are going to consume using REST APIs. Then we'll actually get into the details related to the coding. Keep in mind, we will not only consume data using REST APIs, we'll also process using Pandas, and then we'll actually store the processed data into MongoDB using PyMongo, which is Mongo related library. Now, the website which you have to go with respect to consuming the data is nothing but openmeteo.com. This provides a free weather API. You can see an example here. It says curl and then you can see the endpoint details here. It says api.openmeteo.com/v1/forecast. This is the endpoint. With this endpoint, you can pass the parameters such as latitude, longitude, along with the current, hourly, etc. We'll get into details about all these very soon. First, let's see whether this curl command will work as per the expectations or not. One of the beauty of this is you don't need to even have API key. Without even using API key, you should be able to make the API calls. You can make up to 10,000 API calls per day. However, we don't need to make 10,000 API calls to just build a simple pipeline. We'll just use few API calls per day and we'll make sure we also go to the details about how to schedule so that the job run once every day. That being said, now before going forward, let's make sure we validate this command. When it comes to Windows or even Mac, curl command is available in PowerShell of Windows as well as terminal on Mac. If you are using Mac, you have to open terminal. If you are using Windows, you have to open PowerShell. Then you can copy this. I haven't opened PowerShell yet on this Windows machine. Now let me search for PowerShell. PowerShell is a command line utility which you can use to run commands. First, let's make sure we validate whether curl is available or not. Let me say curl and hit enter. You can see it is available. Let's come out of this. Now let's paste the command which you have copied. This is the command which you have copied, curl and then endpoint followed by all the parameters such as latitude, longitude, current, hourly, etc. You will understand details about these when we get into the details to consume the data from these REST APIs. Now let me hit enter. You can see it is saying OK here and also status code is 200. When it comes to the outcome, you can see the outcome here. It haven't displayed the complete outcome, but it is successful. When we get into the coding, we'll be using something called as request library in Python. We'll be invoking same API to begin with. We will see the actual data at that point in time. This is how you should be able to get started with openmeteo.com, where it provides the weather data in the form of APIs. We'll be using this to actually consume so that we can build the end-to-end pipeline. Before going further, I would highly recommend you to pause here. Make sure you validate by going to openmeteo.com, then copying the command and pasting in PowerShell. You should be able to see the outcome like this. Then only you should go forward. The status code should be 200. Then you should see data like this. Now it is time for us to set up our project and then we'll take it forward. Before getting into the details related to setting up the project, let me first exit from here, and also let me make sure I close this. Now the way I'll start is using VS Code. Once again, I'm reiterating, if you don't have Python and VS Code installed, then you have to pause here, look at the description, you will see a video, make sure you set up both Python as well as VS Code. Also make sure you validate whether both of them are working together or not, then come back and then take it forward. That being said, in my case, VS Code is already installed. Let me first validate by searching for Visual Studio Code here. You can see Visual Studio Code. On top of it, I also wanted to validate Python. Let me close this folder and open a new one. Now the folder which is opened by default is closed. I also wanted to validate Python. The way I can validate Python is again by using PowerShell. Let me go to Windows PowerShell here. Now let me say Python. You can see the Python version which I have is nothing but Python 3.12. You might end up having additional versions of Python or a different version of Python. The latest version of Python is 3.12, but the most popular one as of today is Python 3.10. You can either use Python 3.9 or 3.10 or 3.11 or 3.12 for this project. That being said, now let me click on turn off, and then it is actually gone. Let me come out of this by saying exit. Let me say exit to come out of PowerShell. Now I wanted to open a new folder. Let me click on open folder here. Then let me go to projects. This is my base folder for all my projects. Here let me attempt to create a new folder. For that I have to right click, then say new, then folder. Let me name it as weather pipeline. This is my project name. Now let me click on select folder. Now the project workspace is set up using VS Code. This is how you can actually start with VS Code. However, when it comes to Visual Studio Code, you have to integrate with Python for each project. One of the ways is by using Control-Shift-P. If it is Mac, you have to use Command-Shift-P. If you see Python select interpreter like this, you should be able to select this. Otherwise, you have to search for it. You can say select interpreter or Python select interpreter. And then whenever you see this, you can click on this. Then you can choose the Python environment of your choice. Either you can choose global Python or you can create a new Python virtual environment. In my case, I'll be creating a new Python virtual environment. I will not be using this global Python. To create new Python virtual environment, once the project workspace is set up, you can actually launch the terminal by going to terminal and then by saying new terminal. Now here you should be able to use this command, Python then -m venv. Let's make sure Python is working without any issues. You can see it is working as per the expectations. Now we just have to say Python then -m venv wp-venv. Let me hit enter. It will take care of creating Python virtual environment for this project for us. Once it is created, we should be able to use this for our project. Let's wait until it is fully set up, then we'll take it forward. Now you see it is set up. We can actually say exit. Now we can hit Control-Shift-P. If it is Mac, you have to use Command-Shift-P. Then you have to select Python select interpreter. Then you have to use the Python version from newly created virtual environment, which is nothing but this one. Let me click on this. Now let me click on here to go to terminal, or you can also go to terminal by saying terminal new terminal. However, it is not showing the virtual environment here. That means it is not working as per the expectations. Let me exit once again. Let me try once again. Still it is not working. You can see here Python virtual environment was successfully activated even though wp-venv indicator may not be present in the terminal prompt. So in this case, it is activated, but it is not showing up here. Hence, we can move forward without worrying too much. Typically, it will show what Python virtual environment is activated here, where we have PS. That will actually tell us we are in a specific Python virtual environment, but in this case, it is not displaying for whatever reasons. We don't need to worry too much about it. That being said, in future, whenever we launch terminal, the Python virtual environment will be automatically be activated. As we are ready with the VS Code workspace for our project, now it is time for us to install required libraries so that we can build end-to-end pipeline. As we are going to use Copilot to take care of development, we'll ensure we set up Copilot for this project. The way you can get started with Copilot is like this. you can go to extensions here. Then you can search for Copilot. Let me say Copilot. Now you can see GitHub Copilot here. You have to click on install. It will take care of installing Copilot for us. Once it is installed, you have to sign up for a GitHub Copilot free trial. You have to sign in with your GitHub account. It is mandatory for you to have GitHub account. Only then it will work. Also, after free trial, you are supposed to make the payment so that you can use the full features of Copilot. In most of the organizations, now they are adapting Copilot. Hence, you should be able to use your corporate account if you are already employed and then take it forward. If you are a beginner, you can just sign up using trial version. Try to use as much as you can when trial version is available. After that, if you like it, you can make the payment and take it forward. Otherwise, you can disable and you can keep coding by yourself. I already have paid subscription with respect to Copilot. Once I log in, I should be able to use Copilot without any issues. But before getting into the details with respect to logging in, I wanted to highlight what Copilot is all about. Traditionally, if you wanted to come up with code for our applications, we use Google, we search for the code, then we paste the code, then make the required changes, and then we integrate with our application, validate, then we take care of deploying in the production. In case if we run into any issues while developing the applications, the typical approach is to use Google or Stack Overflow, search for our issues, and then see what is the solution for our issue, then incorporate as part of our application. However, in today's AI world, it is outdated. If you are still following that approach, that means you are not using the power of AI yet. Copilot will streamline all these things with a single interface. You don't need to go to Google and search for the code, and also you don't need to go to websites like Stack Overflow to troubleshoot any issues. Copilot will take care of generating the code automatically. The quality of the code is significantly higher. The changes which you are supposed to make are significantly low when it is compared to getting the code from Google. On top of it, if you run into any issues, you can take the help of Copilot to troubleshoot the issues faster. It provides both code generation capabilities and also capabilities with respect to troubleshooting. It is well integrated with Visual Studio Code Editor. You should be able to use VS Code Editor itself to generate the code. Also, in the sidebar, you will have a chat. You can also use that chat when it comes to troubleshooting the issues. You will understand all those features once we sign up and start using it. So in this case, if you are new to Copilot, make sure you sign up using GitHub account and then take it forward. Here, I'm assuming you already have the account. Then you should be able to select this and then click on sign in. Then click on allow. It is taking us to GitHub portal. Here I have to enter my user ID and then password. It is prompting for the authentication code because I have enabled MFA. Let me pick my authentication code and then I'll take it forward. This is my authentication code. Now you see I'm able to log in. As soon as I'm able to log in, Copilot is enabled. In my case, I have a premium account. Hence, I should be able to use Copilot without much challenges. How to validate whether Copilot is properly set up or not, we'll look into it at a later point in time. It is because you'll be able to use Copilot effectively once you start coming up with programs. Once we install libraries and then come up with a skeleton for the driver program, then we'll enable Copilot and then we'll take it forward. I hope you are enjoying the course so far. In case if you are enjoying, feel free to hit like button and also comment and share with your friends. If you haven't subscribed to our channel yet, make sure to subscribe and also hit on bell icon so that you get notification whenever we upload content like this. Yes, we are ready with Project Workspace. Now it is time for us to install required libraries. First, I'll walk you through the details about why we are installing these libraries. Then I'll take it forward. We'll be using 3 main libraries to take care of reading the data from source using REST APIs, then processing the data, and then writing to target. To read the data from REST APIs, the most popular library is nothing but requests. So we'll take care of installing requests first. On top of it, we'll also install Pandas because once we get data from REST APIs using requests, we wanted to process based on the needs. For that, we might end up using Pandas. Hence, I'll take care of installing Pandas as well. Once the data is processed, we want to write data back to some target database. In this case, we'll be setting up MongoDB database. That being said, to write data into MongoDB database, we have to use some Mongo based library. One of the most popular Mongo based libraries is nothing but PyMongo. So we'll be installing requests, then Pandas, then PyMongo. You can install these in any order, but I'll follow the order which I have highlighted earlier. So in this case, as Python virtual environment is activated, first let's validate whether pip is accessible or not. For that, we should be able to say pip ---- version. Between pip and ---- version, you need to have a space. Then you can hit enter. You can see the version of pip here. It is nothing but 24.0. Now we should be able to say pip install ---- then request. What it will do is, if request is not there, it will just install the latest version. If request is already there, it will upgrade to the latest version. Now let me hit enter. You can see it is taking care of installing request library for us. Along with request, it will also install some additional libraries. You can run this command to review what all are installed. You can see it have installed not only requests, it have installed even urlib3, then IDNI or IDNA, then I think certify also. You can see certify is also installed. On top of it, it have also installed charset -normalizer. So it have installed 5 libraries when we just say pip install request. Now it is time for us to install Pandas. For that, we should be able to use this command pip then install Pandas. It will take care of installing Pandas for us. Let's wait until it is fully installed, then we'll take it forward. Pandas is very big library. You can see it is installing quite a few other libraries as well. The other libraries that are installed so far are nothing but NumPy, then Python dateutil, then PyTZ, then TZ data. Also it have 6 and many other libraries. Let's wait until it is fully installed. I think these are the 6 or 7 libraries which it is going to install. Once all the libraries are installed, then we'll take it further and we'll attempt to install PyMongo as well. Keep in mind, I haven't used --upgrade while install Pandas. However, you can use --upgrade as well in case if you want to upgrade if Pandas already exists. In this case, as it is plain slate, we should be able to use pip install command. It will take care of installing latest version of Pandas because we haven't specified any version with respect to Pandas or even requests. Now it is time for us to install the next library, which is nothing but PyMongo. Once again, I'll be using this command pip install then --upgrade then PyMongo. It will take care of installing this Mongo based library. This will facilitate us to talk to MongoDB database using Python as programming language. It is pretty powerful library. It will streamline the process for us to connect to MongoDB and populate data in the MongoDB tables, also to get data from MongoDB tables. That being said, in case if you want to learn some basics of MongoDB, already we have covered the details about how to install MongoDB and how to perform CRUD operations in MongoDB directly using Mongo shell. You can actually review the videos in the description and then you can take it forward. However, when it comes to integrating MongoDB with Python, I'll be covering in this course. But if you just wanted to go to the details related to setting up MongoDB and also using Mongo shell to take care of CRUD operations in MongoDB, feel free to review the videos that are available in the description. As we have successfully installed all the required libraries, let's make sure to run piplist command. We should be able to see the details with respect to all the libraries that are installed here. You can scroll up and you can see we are interested in requests, then Pandas, and then PyMongo. Now, as we are done with installing libraries, let's get into the details about developing our main program. We will start with Hello World and then we will improvise one step at a time. As we have done all the groundwork, I am now excited to actually get into the development of end-to-end pipeline. For that purpose, first I'll be creating a program. The program name will be app.py or main.py. You can choose one of these. I'll be using app.py. But if your preference is main.py, you can also name it as main.py. Then you can actually say print hello world. Here first I'm validating whether VS Code is successfully integrated with Python or not. Let me save this. Now let me right click and then let me say run Python file in terminal. You can see it have printed hello world as per the expectations. Also, if you observe when it comes to this python.exe command, it is from wp-venv. This is the virtual environment which we have set up for this project. It means we have successfully integrated our project with the Python virtual environment where we have installed all the libraries. Now let me exit from here. Here we have come up with code to quickly validate whether everything is working as per the expectations or not. But when it comes to the actual applications, we'll have this piece of code. Why we need to develop this piece of code? Again, as part of our channel, we already have the details. If you are not familiar about this, feel free to review the video related to this. I'll provide the link in the description. Now let me say if underscore name underscore double equal to underscore main underscore, then I would like to print hello world. Now let me indent here. Let me save this. Let me launch the terminal. In this case, I'm not using right click to run using terminal. Let me say Python, then app.py. You can see it is working as per the expectations. This is how we typically start with developing our application. We need to have this if condition so that it runs without any issues when we use the command line or when we deploy it using some schedulers. That being said, now we need to come up with quite a few functions. We'll be having a function to get data from source, which is nothing but open Meteo. There will be one function for this. Then there will be one function to process data. Then another function for load data into MongoDB. So we have to come up with the three functions for these three purposes. We will also improvise and we'll have additional functions as and when it is required. Now I'll come up with a function by saying def read weather data. This is the function name. We'll update this when we get into the actual logic implementation. For now, I'll just have a function by saying def read weather data, then pass. This function will not do anything. It will just pass. We need to have at least one instruction as part of the functions. That's why we have pass here. In case if you wanted to use some return statement, you can also use the return statement. Then comes process data. When it comes to process data, I wanted to say def process data or process weather data. Let me use weather data here. Again, I'll be saying pass. Then another function to load data into MongoDB. Let me say def, then load weather data. Let me also say pass here. On top of it, I'll also use print statements just to ensure whether everything is working as per the expectations or not. Let me say print reading weather data. Also let me say print processing weather data. Let me copy this. Now let me paste here. Let me update this as loading weather data. Also let me say invoking main function. On top of this, I'll also have a main function. Typically, this if condition will have only few instructions. It will not have too many. We will do whatever it is required and then we'll actually invoke a main function. We'll have a main function which is a driver function to take care of execution of the end-to-end pipeline. So in this case, I'm saying def main print in main function. Then let me say read weather data. Then process weather data, then load weather data. Now let me save this. Let me run this to see if it is working as per the expectations or not. To make sure it runs as per the expectations, I also need to call main function from this if condition. Let me save this. Now let me launch the terminal. Let me say Python app.py. You can see here invoking main function. This is because of the if condition. Then in main function, it is when the control get into the main function. Then we have invoked read weather data, process weather data, and load weather data. These messages are related to those respective functions. You can review the code once again to confirm how everything is working together. Yeah, we have come up with a skeleton. Now it is time for us to get into the details about how to come up with a logic for each of these functions. We'll also improvise and add additional functions in future depending upon the requirements. Keep in mind, these programs are called as driver programs. Also, I haven't used Copilot to generate the code. I have typed each and every line. If you use Copilot, this will be much faster. I haven't used Copilot deliberately so that you understand the difference when I start using the Copilot. As of now, even though Copilot is set up, it is disabled. We'll soon enable and we'll start coming up with code for these functions. That way, we'll speed up our development process using very powerful Copilot as a tool. As we are ready with the skeleton logic in our driver program, it is time for us to start exploring Copilot. The way you can start with Copilot is by going to extensions here. You can see GitHub Copilot and also GitHub Copilot chat. Both of them are disabled. You can see here. You can enable GitHub Copilot by clicking on enable. Also, you need to make sure you have at least GitHub Copilot free trial. If you haven't used GitHub Copilot in the past, using your GitHub account, you should be able to sign up for free trial and use it. I'm not 100% sure about the duration. You can explore by yourself. In my case, I have already paid version. So let me click on this. You can see the details about my account. It is saying you currently have an active Copilot individual subscription. This is how you should be able to get into the subscription. Make sure you have the valid subscription to use Copilot without much challenges. When it comes to enterprises, most of the enterprises have started adapting Copilot. If you are working in one of those companies, you should be able to get the account from your enterprise or organization, and then you should be able to take it forward. Using Copilot can enhance your productivity significantly. With Copilot, you not only get GitHub Copilot, you'll also get something called as GitHub Copilot chat. What is the purpose of it? You will see soon. For now, make sure even GitHub Copilot chat is enabled. First, let us validate GitHub Copilot chat. As soon as it is enabled, you will see this. You should be able to click on this. Then you can actually start chatting with GitHub Copilot. So let me say, hello world. Let's see what it have to say. It seems not working because I think whatever version we have is not compatible with VS Code I have. We might have to upgrade VS Code. I think earlier I have seen that notification. Let's make sure we update VS Code and then we'll take it forward. Now let me say send to new chat. Yeah, now you see it is saying chat failed to load. Please ensure that the GitHub Copilot chat extension is up to date. Now let me click on show extension. Let me click on switch to pre-release version. Let's see what it is going to do. However, it is saying extension is not compatible with code 1.89.1. Extension requires 1.90.0. So here, whatever version which we are going to use, which is nothing but pre-release version, it is expecting to have 1.90.0 when it comes to VS Code. So here we have to upgrade VS Code to make sure we can use GitHub Copilot chat without any issues. The way you can upgrade is like this. Let me say file. Let me see if there are any options to upgrade VS Code. There are no options here. Most likely it will be under help. Let me go to help. Let me see if there is any update message here. It is saying restart to update. Let me click on restart to update. Let's see what happens. I hope it will be updated automatically once we restart. Yeah, you can see here. Now it is saying May 2024 version 1.90. You might already have this, and GitHub Copilot chat automatically might be working for you. But in my case, as I was having 1.89, I have to upgrade it to 1.90 so that I'll be able to use Copilot chat without any issues. Now let me close this. Let me click on this. Now you see it is actually saying welcome, my name, I am your Copilot and I am here to help you get things done faster. So this is one of the features with respect to Copilot. This is not the only feature. There are quite a few other significant capabilities which you should be familiar about. To understand those, let's open app.py here. Then let me select a function. I have selected load weather data function. Let me right click. Then you see there is an option called as Copilot. Here you have several other options. We'll get into those details very soon. For now, we'll just click on explain this. It will actually take care of explaining the code we have. You can see here. The font size is not significant. Let me see if I'll be able to expand this. Now let me attempt to zoom in here. This is not what I wanted to do. That's fine. You can see the text here. this actually explains what that function is all about. And this is only one of many features which Copilot brings in. We'll actually get into the power of Copilot as we get into developing the logic for end-to-end pipeline. I hope you are able to enable and also sign up for the trial version. Make sure you sign up for the trial version before taking it further. I'll be using Copilot quite extensively to come up with end-to-end logic. With Copilot, you will also understand how the productivity can be significantly high to build pipelines like this. As we have successfully integrated our project with GitHub Copilot, now it is time for us to set up MongoDB. I have detailed instructions with respect to setting up MongoDB and also IDE to interact with MongoDB, along with performing CRUD operations in MongoDB using required functions in videos that are already there in ITversity channel. I'll be providing the links to those videos in the description. Feel free to go through those links and ensure you understand the overall process. But for now, I'll also quickly walk you through the details about how to set up MongoDB on Windows. You can also follow similar instructions with respect to Mac. Now, let me open my browser. Then let me go to google.com. Let me say install MongoDB. There is a typo. I need to fix the typo. This is the link I can follow. Let me click on this. Now let me scroll down. Here we are talking about Windows. We'll be installing something called as MongoDB Community Edition on Windows. Let me click on this. Let me scroll down. Here are the instructions to install MongoDB Community Edition. First, you need to download the installer. Then you have to run the MongoDB installer. Then you have to follow the MongoDB Community Edition installation wizard, which will take you through the steps to install MongoDB on Windows. This is how it will look like. Now, let's make sure we scroll up and then click on this MongoDB Download Center. Now we have to scroll down. The version is nothing but 7.0.11. The platform is nothing but Windows x64. The package is nothing but MSI. Make sure these values are selected if you are using Windows. If you are using Mac, you should see the details with respect to Mac. However, when it comes to Mac, you can also install using Brew. That being said, now let me click on download. The download is started. You can see here. We need to wait until it is fully downloaded. Once it is fully downloaded, then we'll actually follow the instructions to take care of the installation. The next step after download is nothing but this one. We need to make sure we run the MongoDB installer. Let's wait until it is fully downloaded. You should be able to click on this at any point in time. It is almost done. As soon as it is done, we should be able to go to downloads and then we should be able to take care of installation. Now the download is done. We just have to click on this to go to downloads. You can see here, we should be able to double click on this. Let's wait until it starts the installation. Now we just have to follow the wizard. This is the third step. Once we download, we just need to make sure we go to downloads and double click on the installer. It is called as MSI. MSI stands for Microsoft Installer. Once you double click on this, it will open the wizard. We just have to follow the typical path here. Let's accept and then click on next. Then let's make sure we choose complete. Then click on next. Then click on next. Then install. You see, it has started the installation of MongoDB Community Edition on this Windows machine. We have to click on yes. Let's wait until installation is fully done. It will take few minutes. Once we are done with it, then we'll take it to the next step. Now the installation is successfully done. Let me click on finish. Let me click on start so that Compass is started. We can click on connect to the MongoDB as well. With the latest version of MongoDB, it have automatically installed IDE as well. And you can see using IDE, we are able to connect to MongoDB server that is connected locally. You can review the details here. In case if you wanted to create a demo database just to validate whether it is working as per the expectations or not, you can click on this plus beside databases. Then you can give name to the database. Let's say demo. Then let's give collection name as users. Then let's click on create database. It will take care of creating the database by name demo with collection users. Now you can see the details with respect to users here. As there is no data in users, you are not seeing anything here. You might be confused about what is this collection. The collection is similar to database tables which you have seen earlier if you are experienced with traditional databases. However, when it comes to collections, in contrast to database tables, we don't need to specify column names and data types to begin with. As we populate the data depending upon the data that is passed, it will be able to determine the names as well as data types for each and every column in these collections. Collections are similar to tables but not exactly tables. One main difference is nothing but schema. When it comes to tables, the schema is predefined. When it comes to collections, the schema is not predefined. Also, when it comes to tables, you will mostly have fixed schema. When it comes to collections in MongoDB, you don't have fixed schema. It is quite flexible. You should be able to have different columns for different records when it comes to collections, which is not possible with respect to tables. So don't worry too much about learning MongoDB at this point in time. The course is primarily to populate data into MongoDB once data is consumed from REST API and processed. However, if you want to learn MongoDB, already we have content on our YouTube channel. I'll be providing the link in the description. You can follow that link and learn some of the basics with respect to MongoDB. That being said, as MongoDB is successfully set up, now it is time for us to get into the details about the overall development of our pipeline. Once we develop the pipeline, we'll also ensure it is validated, and also I'll cover some of the aspects with respect to scheduling the pipelines. That being said, make sure you watch the course till the end to get best out of this course. If you haven't subscribed to our channel yet, make sure to subscribe and also hit on bell icon. You will be notified whenever we upload content like this. As we are ready with MongoDB, before going further, let's also make sure we spend some time in understanding what MongoDB is all about. Keep in mind, I'll be only scratching the surface. I'll not be getting into too many details with respect to MongoDB. However, in case if you wanted to learn MongoDB in detail, stay tuned. We'll be publishing a lot more content around MongoDB in our channel. You just have to subscribe to our channel and hit on bell icon so that you are notified whenever we provide the content. Also, look at the description. You might end up getting a few courses around MongoDB. That being said, when it comes to MongoDB, it is a NoSQL document-oriented database. You don't see tables and records in MongoDB databases. We typically see collections and documents. When it comes to collection, it is nothing but a group of documents. Now let's spend some time around collection and documents. Collection is similar to table in typical database world. However, when it comes to documents, they are similar to records. So a collection is a group of documents. The reason why they use the term document rather than record is because when it comes to document, it is semi-structured, whereas the records in the tables are structured. Also, as I have mentioned to you earlier, when it comes to documents in MongoDB collections, they don't have predefined schema. Each record can have different column names and values of different data types. There is no rigid schema when it comes to MongoDB collections. One of the common questions you get is, already we have so many different types of RDBMS databases. Why use MongoDB over them? For some applications, schema is not important. If you try to use traditional RDBMSs, there is overhead about creating the tables. The tables comes with predefined schema. Whenever there are changes to schema, you have to make changes to the tables, and at the time you might have to bring the application down. For those scenarios where we don't need predefined schema, using MongoDB as a database can be better when it comes to development productivity. Also, from the performance perspective, it might perform better compared to traditional RDBMSs. There are a number of reasons for certain set of applications where MongoDB is more appropriate compared to traditional RDBMSs. However, I don't want to get into all those details at this juncture, but I wanted to give quick overview about what MongoDB is all about. Even if you don't understand most part of the theory, just make sure you understand MongoDB is a database where you have collections. Each collection contain documents. Collection is similar to typical RDBMS table. Document is similar to record in the table. Also keep in mind, the collection doesn't have predefined schema unlike RDBMS tables. As long as you understand these details, we can move forward and build the applications without much challenges. Also, before going further, let's understand how to populate data into the MongoDB collections using IDEs such as Mongo Compass. We can also use Mongo Shell. However, I'll not be covering the details with respect to Mongo Shell. Again, we'll be coming up with a basic level course with respect to MongoDB, where you will understand details with respect to MongoDB in detail. Look at the description, click on the link and then learn. For now, to populate data into this collection called as users, we just have to click on add data. If you already have JSON or CSV file, you should be able to use this option to import data from JSON or CSV file. However, we don't have any JSON or CSV, hence I am clicking on insert document. Here you can see a template. You should be able to use this template to come up with required code to insert a document into Mongo collection. You see there is the ID, and ID is based on this one. you can leave it as is. You don't need to worry about changing this. Then let's say this is users collection. Hence, we wanted to have username. We should be able to say first name. In this case, I'm referring to first name, not username. And then I should be able to specify the name here. The name is nothing but Durga. I have to use double quotes. Then I will also add one more column, which is nothing but last name. In this case, last name is nothing but this one. Also, I would like to add email ID. Let me say email. The email ID is nothing but dgadiraju@itversity.com. Like that, you can add as many attributes as you want with corresponding values. Keep in mind, this is similar to JSON. JSON stands for JavaScript Object Notation. It is similar to Python dict. You will have attribute names. These are all attribute names. After attribute names, you typically specify column. Then you will have value. The value can be another JSON document or it can be simple string like this. So in this case, this is nothing but another nested JSON document. This is just string. This is another string. This is another string. On top of string type, you can also specify numeric types. Also, it supports date data types. So these are the typical data types which we typically use when it comes to values. When it comes to attributes also, they can be of different types, but typically we use strings only like this. Keep in mind, underscore ID is primary key or the key in the Mongo collection. It will automatically be included even if you don't define it. It will take care of inserting a unique value into it. Now let me clean this up. Now let me say insert. You can see that document is inserted into Mongo collection without any issues. Even though I have removed underscore ID, you can see underscore ID here. And this is the corresponding value with respect to underscore ID. It is unique across all the collections in MongoDB database. Then we also have first name, last name, and email with corresponding values. And this is how you should be able to use this interface to insert individual records. But typically we import or we use programs to populate data into Mongo collections. However, to begin with, we should be able to even use this approach to insert individual records into the Mongo collection. As we have gone through quite a few important details with respect to MongoDB, now it is time for us to understand how we can actually interact with MongoDB using Python as programming language. We will soon get into the details about building the end-to-end pipeline, but first I wanted to cover some of the basics with respect to interacting with MongoDB, not only using IDE like this, but also using Python as programming language. As we have gone through overview about MongoDB database, now it is time for us to understand how we can start with Python to interact with MongoDB. For that, I'll be using VS Code. Let me open my VS Code. In this, I'll be creating a new file. This will be MongoDB 101.ipynb. Keep in mind, VS Code supports Jupyter notebooks. In this case, we are creating Jupyter notebook by name MongoDB 101. Now we have to select the kernel. For that, we can click on this and then choose the appropriate kernel. Let me click on this one to install or enable suggested extensions. It will take care of installing the extensions for us. You can see here, it have started installing the extensions. It will take a bit of time. Once the extensions are installed, we can take it further. Now the extension is installed. We just have to click on Python environments and then choose the appropriate Python environment. My Python environment name is nothing but wp-venv. Let me click on this. Now the kernel is activated. We also need to click on hello here. Now let's start with print hello world. Also, if you see the message, it is saying press Ctrl+I to ask GitHub Copilot to do something. You can start typing to dismiss. First, let me say print hello world. We need to click on install once again. It will take care of installing something called as ipykernel extension. You can see here. It will take a bit of time. Once it is installed, then it will run without any issues. It will just take few seconds to install ipykernel package in this environment. If you are already an experienced professional, this might be redundant for you. The only reason why I am actually covering all these aspects is to not to break the flow. Now you see it have printed hello world. We should be able to say Ctrl+I. You see it have popped up this text box where we can ask a question and it will come up with the code accordingly. So here connect to MongoDB and query data from users collection. It is available in localhost. Localhost means our system where MongoDB is already installed. Now let me hit enter. it will automatically generate the code for us. This is one of the main feature of Copilot. You can see code is generated successfully. Within few seconds, this entire code came up onto the screen. If you have to develop the code, it might take a few minutes at the least. That being said, as we haven't specified the database name while prompting, it have said your database name. However, the database which you have created is nothing but a demo. See here. Hence, we have to update this. Apart from this, we don't need to change anything else in this code. Now let's go to the code. Here it is attempting to connect to MongoDB. Here it is attempting to access demo database. Using demo database, it is attempting to access users collection. Then it is submitting a query against Mongo collection. And this is the way where you can actually submit the query against Mongo collection using Python. Here query is empty dict. Then collection.find query is the one which is going to go to MongoDB and fetch the data. It means it will try to fetch all the records in the Mongo collection. In case if you wanted to add filters, you have to update this and then pass here. Result is nothing but iterable. Here it is iterating through result and then printing individual documents. Now we should be able to save this, and then as we are using notebook environment, we should be able to click on this to run. You can see the result. The result is as per the expectations. Whatever document we have populated into users collection in DemoDB by using this interface is now retrieved using Python as programming language. This is how you should be able to interact with MongoDB database. If you feel this code is complex, probably you might have to brush up your Python skills. In case if you are not comfortable with Python, at IT University we have full-blown course as part of our channel. We'll be providing the link in the description. You just click on the link, learn Python that is required for data engineering. Then all this code will start making sense to you. I will not be getting into too many details to explain each and every piece of code I'm going to develop. In the process of understanding how to connect to MongoDB using Python, we have even explored the power of Copilot. Copilot is quite powerful. We'll use it extensively to build end-to-end pipeline within a quick turnaround time. If you have any questions around Copilot, reach out to us. We'll be there to help you. Also, I would suggest you to share your opinion around Copilot. If not now, at least in future, as we start using it extensively, whenever you get a chance, don't forget to share your feedback about Copilot. As we have understood how to connect to MongoDB using Python, now it is time for us to understand how to use Python to consume data from OpenMeteo. Let's review OpenMeteo once again and then we'll take it forward. Here I am going to browser. Let me go to open-meteo.com. This is the main URL. This actually provides free weather APIs. You can see the example here. Already we have gone through this. We should be able to copy paste and it will run without any issues. Now let's try to interpret this. But before interpreting it, let me run once again. Here I am copying this. Then I am going to terminal here. As part of the terminal, I'll be running this curl command. Now you see it is running. You can see the outcome. The status code is 200. It is very important for you to review status code. It should always be 200 or similar to that. It should not be something related to error. You can also confirm whether it is successful or not by looking at the description. And then you can also review the content. As part of the content, it have latitude, longitude, generation time, so on and so forth. Now let's try to get a similar outcome using Python's request library and then we'll take it forward. But before getting in there, let's review the parameters that are being passed to curl. As part of curl, we have passed this string as parameter. This highlighted section is nothing but endpoint to get weather related information from OpenMeteo. It takes several parameters. The parameters are nothing but latitude. You can see here there is latitude, then longitude. On top of latitude and longitude, we have current and also we have hourly. Current means it will give us current temperature details between this latitude and longitude, which means ACT. Also, it gives hourly details. Let's use request and start consuming this data. We'll go to the outcome and you'll understand what I'm talking about here. Let me close this. Again, I'll be using a new notebook. Let me close these. In this case, I'll be saying open Meteo 101.ipynb. Now notebook is created. Let's make sure we choose appropriate kernel. It is nothing but this one. Let's say Control I. Please use requests and consume data from this endpoint. Already I have copied the endpoint. I am just pasting it. In this case, along with endpoint, we also have parameters such as latitude, longitude, current, hourly, etc. Keep in mind, latitude and longitude are related to cities. Now we should be able to click on this or hit enter. It will take care of generating the code for us. Already we have installed request library in our virtual environment. Hence, it will work without any issues. Now let's click on accept. You can see the outcome. Import request, then URL is nothing but whatever URL we have specified while prompting. Then this is the code request.get with URL will actually make the API call and get the outcome. The outcome will be assigned to response. Whatever we have seen from the perspective of status code here, that is exposed through attribute called as status code within response. Also, as part of the result, we have content. You can see the content here. Where is the content? The outcome got messed up. This is all related to content, but it is not showing properly. Don't worry too much about it. Earlier you have seen. If you want, you can go back in the video and see how the content look like. Now let's go back to the notebook. So the content which you are seeing as part of the outcome is exposed through JSON. This will actually return the content into variable called as data. This is of type dict. Here we are printing the data which is of type dict, which contain the response that is returned by this REST API. When I say response, the main content of the response, not the whole response itself. That being said, for whatever reason, if the API call is failed, it will go to else. The status code will be something else than 200. It will just print error and it will also print status code. Now let's run this to see if it run as per the expectations or not. You can see the outcome. It is as per the expectations. You can actually scroll towards right and see all the details that are returned. We also have something called as pprint. We can actually select this and then say Control I. Improvise using pprint so that the outcome that is printed is reader friendly. Let's see what happens. It is generating the code again. Now you see it have updated as per the expectations. We can say accept. It have imported pprint here and then it is using pprint.pprint to print the data. Now let's run this. The outcome is better. It is definitely more reader friendly compared to what we have seen earlier. The first attribute in the outcome is nothing but current. You have all current details here, the interval, the temperature, the time, wind speed, etc. Also, there is another attribute which is nothing but current units. These are units for these attributes. For interval, it is seconds. For temperature _ 2m, it is Celsius. In the similar fashion, you can review the details with respect to units for time and wind speed _ 10m by looking at these details. On top of current and current units, we also have elevation, generation time _ ms, then hourly details. So here we are invoking forecast not only with current but also hourly. So you can see hourly details here. This is with respect to humidity. You also might have other information. To review all the information, either you have to click on a scrollable element or you have to click on text editor. I prefer text editor. Let me click on text editor and you can see here. It have provided all the details with respect to something called as relative humidity. These are all related to relative humidity. Also scroll down and see details with respect to others. The outcome is pretty big. Now you can see temperature _ 2m. Let's scroll down. You can also see the time here. So we said hourly and you can see the details with respect to each and every hour for which we got details such as relative humidity, temperature, etc. We will interpret all these details in future. For now, let's close this. We have successfully invoked REST API against Open Meteo using requests. In case if you are not comfortable with requests or even collections in Python, feel free to review the videos we have published as part of our channel. You can go to the description and find the videos. Once you learn Python, all this code will be fairly straightforward. That being said, using Copilot, we are able to come up with this code within a few seconds. If you have to develop all this by yourself, it will take a bit of time. I hope you are enjoying the content. If yes, like, comment and share. In case if you haven't subscribed to our channel yet, make sure to subscribe and also hit on bell icon. Whenever we upload this type of content, you will be notified. As we have understood how to invoke REST APIs using requests, let's quickly recap details about REST APIs. When it comes to REST APIs, there is GET, Get is primarily to read the data from another web service. Then we have put as well as post. Put or post are typically used to either insert or update or both. Then we have delete. Delete is primarily to delete data from a web service. So these are the most popular REST API calls which we typically use. However, there are others also. The examples for others are nothing but patch, and there are a couple of others as well. But get, put or post and delete are the most popular ones. When it comes to building pipelines, we typically focus on get to read the data. In some cases, we might have to write the processed data back to some other web service. In those scenarios, we might end up using put or post. But in most of the cases, we use get. When it comes to security, while using REST APIs, either we use something called as tokens or API keys. API keys is more appropriate word. On top of API keys or tokens, we also use something called as client ID and secret. So there are multiple ways to authenticate when it comes to REST APIs. In most of the cases, we use API keys. In some cases, we might end up using client ID and client secret or access key and access secret, so on and so forth. That being said, in most of the cases, you have to get authenticated to use REST APIs. But with Open Meteo, it is an exception. You don't need to pass anything for the security. Even without getting authenticated, you can make 10,000 calls per day and you can consume a lot of weather data from openmeteo.com. This is quick recap of REST APIs. Once again, if you wanted to know more about REST APIs, how to invoke REST APIs when security is involved in the form of API keys or other form, all those things are covered in our main Python courses. You can actually look at the description and follow the links related to Python courses and learn all this good stuff. For now, let's move on. Let's make sure we come up with required logic to consume data using REST APIs. Then we'll see how to process the data before loading into target, which is nothing but MongoDB. Also, before we move forward, let's review the code here. Here we are using get, which means we are making a get API call using requests. In the similar fashion, you can either use put, post or delete. Depending upon your requirements, you should be able to use the appropriate API. In many cases, you have to use authentication as well. For this, you don't need to use authentication. As we have gone through details about how to invoke REST APIs using requests and also how to load data into MongoDB using PyMongo, now it is time for us to review the REST API and come up with a plan to get the data from Open Meteo, process it based on the requirement, and then load it into MongoDB. We need to have some structure when data is being loaded into MongoDB. Just storing this data into MongoDB doesn't make any sense. That being said, let's go through openmeteo.com once again. You can see here, when it comes to parameters, we have latitude and longitude, not city. Each city have its own latitude and longitude. First, we need to come up with mapping between city and latitude as well as longitude. Using that information, we should be able to build these APIs. Keep in mind the combination of latitude and longitude is known as coordinates. So each city will have coordinates. We'll store this mapping either in a file or a table. When it comes to the flow, it will be something like this. First, we'll get the coordinates for a given city. Using the coordinates along with other parameters, we'll make a API call to get the data. We'll try to get the data for T-2, which means day before yesterday. As of today, it is 25th. We'll try to get the data for 23rd. We'll get hourly data for 23rd. We'll stick to temperature and probably wind and few additional weather-related parameters. We will use this information to store into MongoDB collection. When it comes to storing this data in a MongoDB collection, this is how it will be stored. There will be 24 records for each city. Each record will have details with respect to temperature and a few additional weather-related parameters. You will understand what I am talking about once we start getting into the details. For now, let's make sure we identify the API which we are supposed to use based on the needs. Then we'll take it further. Here, I am scrolling down. Let me click on read the docs. It will take us to the actual API documentation. Here, you can actually specify latitude, longitude. If you want, you can also specify the time zone. We'll be using GMT only when we attempt to store in the database. You can select whatever you wanted to select. In this case, I wanted to choose temperature. Then let's also check other aspects, probably precipitation, then rain. Like this, you can choose whatever you wanted to choose. Now, let me scroll down. Here, you can choose Python to get sample code. However, the code is based on something called as Open Meteo request, not the request itself. Using ChatGPT, we should be able to come up with the code without much challenges. First, let me zoom in a little bit here. Now it is better. You can review the code which is based on open Meteo _ request. As we'll be using ChatGPT, we don't need to worry too much. Even with request library, we should be able to come up with this logic very quickly using ChatGPT. So if you review the parameters beyond endpoint, this is endpoint. Endpoint is assigned to a variable called as URL. Parameters contain latitude, longitude, and hourly. As part of hourly, we have temperature 2M, precipitation, and rain. So it will actually get us 1 week forecast from now with respect to these 3 every hour. Now I wanted to get data for T-2. The way you can validate is like this. You can scroll up. Here you can go to time interval. Go to 23rd of June. Let me make sure I select this. Then end date is also 23rd June. It will actually get the data for each and every hour within that June 23rd. Now let me scroll down. If you say 24, it will get data for 2 days. You can see it has start date and end date parameters. This will give us an idea about how we can actually come up with parameters to get data using request library. So these are the parameter names which you are supposed to use, and also these are the values. These are supposed to be variables based on the city for which we are trying to get weather related information. These can be hard coded. When it comes to start date and end date, these are supposed to be changing every day. Whenever we schedule, we are supposed to get data for T-2. It means this has to be changing every day. If it is 25th of June, this should be 23rd of June. If today is 26th of June, this should be 24th of June, so and so forth. We have to come up with logic to change the date dynamically. There are multiple ways to take care of it. Either you can use bookmarking approach, or you can just follow T-2 approach. We'll be following T-2 approach for now to build the pipeline. That being said, as we have reviewed quite a few important details with respect to these parameters, now let's get into the code as well. Let's try to get information with respect to the same city, whatever is there with this latitude and longitude, and see whether it will return the results as per the expectations or not. Then we'll take it forward. First, let me make sure to copy this. Now it is copied. Let me go here. Let me paste here. Let's run this. Now params is created. We should be able to say Control I and then come up with a prompt saying, please come up with code using requests to get the data from Open Meteo based on params. Now let's hit enter. You see the code is being generated. Let's wait until the code is generated. You can see the code is getting generated. Let's say accept and then let's run this. You can see the outcome as per the expectations. We got current and also we got hourly. Let's see how many values we have with respect to hourly. Let's also review params once again. As part of the params, we have temperature _2M, precipitation and rain. We should be only getting those. It have also included current. I don't know why it have included current, because we haven't mentioned about current. I think it have used this URL itself. I need to make sure I fix the URL as well. So in this case, let me copy this. Let me scroll down. Let me add one more cell here. Let me say URL equal to. Then let me paste. This is the URL. Now let's attempt to run this. Let's see what happens. This time it haven't returned current, which means this is correct. Now let me scroll down. Let me click on text editor. Let's look at the precipitation, rain, and also temperature. We have 24 entries. Each entry is related to each hour on 2024 June 23rd. You can see 24 elements here. Also, you can see the units related to whatever we are getting. So these are the units for precipitation, mm. When it comes to rain also it is mm. Temperature is degrees Celsius. Time is nothing but this one. Also, you can see the details related to latitude, longitude, etc. This is how you should be able to improvise on the API. However, the outcome is still not structured. We need to make sure the outcome is transformed into a proper structure. Then we'll actually get into the details about populating the data into MongoDB, where for each city there will be 24 records. But before getting into the details, I would take the help of Copilot again, get the coordinates for 5 cities. Then store the data in MongoDB database with respect to those 5 cities. Then for those 5 cities, I'll attempt to get the data dynamically. First, I'll attempt to get for one. Then I'll improvise to get for multiple cities. Now let's attempt to get coordinates for 6 to 7 cities across the globe. We'll be using Copilot for the same. We'll be picking Delhi from India. Then when it comes to US, we'll be picking Dallas. On top of these two, we'll be picking London from Europe. Also, we'll be picking Johannesburg from South Africa, Dubai from Middle East, and Sydney from Australia. So for these 6 cities, we will attempt to get coordinates. We'll be using Copilot chat. Here we can click on this to go to Copilot chat. You can see here, we can actually go to main editor by clicking on this and then by clicking on open chat in editor. Now chat is in editor. Let me zoom in here. Now I should be able to come up with a prompt. Please provide coordinates for Delhi. You should be able to see the details here. These are the coordinates for Delhi. We can also come up with coordinates for other cities which we have discussed. Now, please provide coordinates in the form of JSON array for below cities. They are nothing but Delhi, then Dubai, then Dallas, then Sydney, London, Johannesburg. Now let me hit enter. You should be able to see the coordinates here. You can also use Copilot directly within notebooks also, but in this case I wanted to demonstrate the usage of Copilot chat as well. You can prompt for non-code related scenarios using Copilot chat. Now you got the JSON array. In case if you wanted to come up with the code using Copilot chat, you can also ask about how to populate this data into MongoDB collection. It will provide you the code. However, I'll copy this. Then I'll go to my notebook, which is nothing but MongoDB 101. Let me zoom out a little bit here. Now let me add one more cell. Let me paste here. Let me assign to variable called as city coordinates. In this case, it will be automatically be of type Python list. Each element in this Python list is of type Python dict. We should be able to process this data using typical Python collection APIs, or we should be able to even use Pandas. Make sure to run this. In this case, I'll be coming up with code using Python-based collections. For that reason, I'll say Control I here. Then I'll send the prompt saying provide the code to populate this data into MongoDB collection by name city coordinates. When it comes to the database name will be weather_db. Please provide code to populate the data into Mongo collection city coordinates in database weather_db. Now let me run this. The code is successfully generated. You can review the details here. It seems to be fine. Let me click on accept. Now let me review. It have imported PyMongo. Here it is attempting to connect to MongoDB database. It will be using WeatherDB database. Then it will be using city coordinates collection. Using the collection which is based on city coordinates, it is invoking insert_many and it is passing a list of dicts to it. The list of dicts is nothing but JSON array. You can see here this list of dicts have 6 elements. Each element is of type dict. This is how you can interpret from the Python perspective, but from JSON perspective, it is nothing but JSON array with 6 JSON documents. All these 6 JSON documents will be loaded as documents in MongoDB. Let's run this code. Also, if you review, it have this for loop which is trying to fetch the data from city coordinates and then it is printing each document separately. We should be able to even review whether data is populated successfully or not using this piece of code. In this case, I'm running this. You can see the outcome. It have returned 6 documents. Each document have city, latitude and longitude along with ID. That being said, we can also go to Mongo Compass. Let me go to Mongo Compass here. Now let me refresh this. Now we should be able to see WeatherDB. You can see WeatherDB. Let's expand, click on city coordinates. Now you can see all the 6 documents here. Using Copilot features such as chat and also code generation, we have not only generated coordinates for cities, we are able to even come up with code to populate into Mongo collection. if you practice enough, you should be able to get this done in few minutes. Using a traditional approach without Copilot, it would have taken at least a couple of hours. That being said, now it is time for us to go to next step. We'll start working on functions in app.py. First, we'll focus on read weather data, then we'll get into process weather data, then we will see how to improvise by updating load weather data to load data into MongoDB collection. With the help of Copilot, we are making quick and steady progress to build end-to-end pipelines using technologies like Python and MongoDB. Stay tuned until the end of the course so that you understand the overall process in building end-to-end pipelines. Now let's start working on app.py. The first step is nothing but to read the city level details from MongoDB. We'll come up with a function for that and then we'll take it forward. In this app.py, you don't have a function for that. Let's make sure we define a new function. Before defining the new function, I'll import request library. Let me say import request, and also I'll be importing PyMongo. Now I'll be defining a function to get city details from Mongo collection. In this case, the database is nothing but weather_db. If you recollect, that is the database which we have created while populating city coordinate details in a table called as city coordinates or collection called as city coordinates. We have mentioned the database name here. Also, we'll mention collection name. Let me say collection is city_coordinates. Now, you see, it have given this piece of code, but we wanted to improvise further. Let's take care of it. As soon as I hit tab, all these things are auto-filled. It is because of the Copilot. Now, let's delete this. In this case, I'm removing pass. Now, let me say connect to MongoDB and get city coordinate details or city coordinates. Let's see what happens. In this case, it is suggesting the code. We just need to take care of hitting tab to fill the code. Now DB is created, which is nothing but database object. Collection is created, which is nothing but collection object. See here, it have used weather DB, which is nothing but database name, and also city coordinates, which is nothing but collection name. We have mentioned these names here. So the same names are used here. Instead of this approach, I would like to mention the database name and collection name in square brackets like this. You see, it have automatically filled as soon as I type the square brackets and then I type single quotes. As soon as it suggests, if we hit tab, it will take care of filling those details. Otherwise, we have to type. As we type, it will keep on suggesting, but whatever we are typing will take precedence. As we are able to create collection object, it is time for us to get details of all cities. Let me say get details for all cities in the collection into a list called as city details. Now let me hit enter. Now let me hit tab here. It will fetch details about all cities. I am not 100% sure about the type of city underscore details. If I move my cursor here, it is saying cursor. I wanted to create a typical Python list. Hence, let me hit enter. Now let's see what happens. In this case, the name is not correct. It is supposed to be list by name city details, but this is not of type list. It is of type cursor. Let me actually say results. Then let me hit enter. Let me hit tab. So it have initialized empty list by name city underscore details. Now it have come up with for loop to update this city underscore details. All the results will be assigned to this list. Let me hit tab. Now the code is ready. We need to make sure this is returned. Let me say return city underscore details. So here we will not be using a city name as the argument because we are attempting to get details of all cities. This argument and the function name could be the reason why it haven't generated good quality code to begin with. Let's fix it. Let's remove city name. Also, let me say get all cities. The more appropriate name is nothing but get all cities. Let me also rename this as get all cities. I'm using rename symbol here and then saying all underscore cities. You can see it is updated everywhere we have city underscore details. So this is how you should be able to come up with the code to get details of all cities from Mongo collection. Here also we should have mentioned get details of all cities. And here also you can say connect to MongoDB and get details for all cities. If we have used proper English, then we would have got good quality code in the beginning itself. However, we have fixed by reviewing the code. That being said, let's save this. It is time for us to validate. So in this case, as part of the main function, I'll actually invoke that. Let me say all underscore cities equal to get all cities. Let's save this. Then we'll also process the result and print the result. For that purpose, I can say for city in all underscore cities, print city. Now let's save this. This is primarily to test whether it is working as per the expectations or not. Once we validate, we'll take the next step. Now let me click on this to go to the terminal. Let me clear the screen. Now let me say Python app.py and hit enter. It will run the code and you can see details about all the cities here. Yes, we are ready with the function to fetch details about all cities. Now it is time for us to go to next step. As part of the next step, we will see how to build a required endpoint and make a REST API call against Meteo to get details for a particular city within a given date range. Once that is done, we'll also take care of processing the data, and also we will see how to save the processed data into the MongoDB. Make sure to watch the entire video to understand all these important aspects when it comes to building data pipelines using Python as programming language. Keep in mind, we are using Copilot to boost our productivity. Yes, we are ready with the function to get details of all cities. Now it is time for us to update read weather data function to fetch the details for a given city based on the parameters. Let's review the Open Meteo 101.ipynb. You can see params here. Let's copy this. Let's make sure we paste here. Let's also make sure we format this. Now everything is indented properly. When it comes to latitude and longitude, we need to use details from all cities. Already you can see there is all cities here. We can actually clean this up. Then with respect to read weather data, we need to pass one city at a time. For that reason, we just have to say for city in all cities. Then we need to make sure we indent under for loop so that these are invoked for each city. One of the parameters should be city. If you want to pass any other parameters, you can also pass other parameters as well. For now, we'll just use city. We already have params here. City will be the argument or parameter here. So here the city details are passed using city. Now we should be able to say city of latitude to get latitude, because the column name is nothing but latitude. You can review by going to Mongo Compass. We have latitude and longitude. Let's make sure we say city of latitude here. Then when it comes to this one, it should be city of longitude. Then when it comes to start date and end date, let's keep 2024 June 23rd itself so that we validate whether the APIs are working as per the expectations or not. Now here you can actually specify docstring. This is one way to actually streamline the process of coming up with docstring, and then using that as reference, it will be able to generate the code for us. So in this case, I am specifying the docstring in triple quotes. So here we are saying, yeah, it is supposed to be reading weather data from Open Meteo. When it comes to the design, it is nothing but use city coordinates to get weather data. When it comes to URL, it should be this one. Let's go here. The URL is nothing but this. Let's copy this and paste here. Now URL is also specified. Let's move the print statement to the top. I am pasting the print statement here. We can remove pass because we will be coming up with the code to fetch the data by invoking REST API call. You see it have automatically suggested. We just have to hit tab to fill. Then we should be able to come up with the if condition to see if the status code is 200 or not. For that, we can come up with a logic like this. If, see here, it have automatically suggested the code which we are looking for. Let's hit tab. In this case, instead of printing weather data, we'll be returning the weather data. Return weather data. Else, we can say return none. So it will not return anything. We'll actually improvise by adding exceptions. I'll talk about those details at a later point in time. For now, if status code is not 200, we are just returning none. We also need to make changes in main function. Let's comment these two things out. As of now, process weather data and load weather data doesn't have any business logic. Hence, we have commented these two things out. When it comes to read weather data, if the API call is successful, it will return dict object. Let's make sure we capture and assign to a variable. Let's say weather data equal to read weather data of city. I would like to use pprint to print the details from weather data. For that purpose, first I need to import pprint. Let me say from pprint import pprint. Then we need to make sure we use pprint to print the details of weather data. Let me say pprint of weather data. We have made all the important changes with respect to read weather data and also main function. As we are done with reading weather data for a given city by invoking the REST API, it is time for us to validate. Let's get into terminal here. Then let's say Python app.py to validate. This time we should be able to see the weather data for each of the cities. You can go to the details here. You can review whether each of the details are related to a specific city or not by focusing on latitude and longitude. This is with respect to one city. Now let's review another city, which is nothing but this one. In this case, you can see the latitude and longitude are different, which means it is able to connect to Open Meteo and get the details using REST API calls for each of the cities. Yes, we are done with required changes related to read weather data. Now it is time for us to go through process weather data. Keep in mind, we haven't made the dates dynamic yet. We'll actually take care of making the dates dynamic at a later point in time. That being said, read, process, and then write to MongoDB. These are the high-level steps which you need to keep in mind when it comes to any data pipeline. As of now, we are able to come up with a logic to read the data for a given city using REST API from Open Meteo. Now it is time for us to design the data model using MongoDB. First, we need to understand the requirement and then we have to take it forward. In this case, we want to store hourly data for each city each day, which means for each city per day, there will be 24 records, one per each hour or hour. That being said, based on this, let's go ahead and use Copilot chat to come up with the data model for MongoDB. Here, I am exiting from this. Then I am actually clicking on this to go to Copilot chat. Let me close this. Let me click on Open chat in editor. Let me zoom in a little bit here. Let's also pick the params which we are using. For that, we have to go to app.py. Then we have to pick the params. The params are there as part of read weather data. This is what we are going to copy. Let's copy this. Now let's go to the chat. In the chat, let's ask Copilot to give us the data model to store the outcome in MongoDB. Using the below params, please provide data model to store the outcome from Open Meteo in MongoDB table or collection. The collection should have 24 records for each city and day combination. Now let's paste here. In this case, we have pasted the params. Let's hit enter and see what it have to say. We need to review and confirm if everything is appropriate or not. You can see the outcome here. It is suggesting to use city, date, and data attributes. With respect to city, we'll be having city name. With respect to date, we'll be having the date. Then for each date, we are going to have the data in JSON array. So in this case, the data will have 24 elements for each city, for each date. Let's scroll down. You can see the details with respect to all the records within the array. It have displayed first two and then last one. 0 means midnight, 1 means 1 a.m., 23 means 11 p.m. Now, it have automatically suggested the next question. It is nothing but what is the process to connect to a MongoDB database using Python. If you wanted to click on this and get the result, you can do so. However, we don't want to ask this because we are already familiar about how to connect to MongoDB database. But eventually, we'll ask for the code to transform the data from the outcome to this, and also we'll ask for code to use this to load into MongoDB database, and we'll incorporate as part of our data pipeline. This is another very important feature of Copilot. You should be able to use it for designing your applications. It will also provide physical data models like the tables or collections which we have just come up with. Make sure you are fairly comfortable with not only Copilot within your code, but also Copilot chat to work with it in the process of design or even requirement analysis or even testing your applications thoroughly. It can help you in many ways to boost your productivity with respect to building your applications. Before moving on to the next step, let's also understand what should be the collection name. Again, we should be able to use Copilot chat itself for that. In this case, you can ask a follow-up question, which is nothing but, can you suggest a meaningful name for the collection? Let me hit enter. Let's see what it have to say. It is saying city weather hourly. If you like it, you can use it. Otherwise, you can also ask for few more suggestions. Can you provide 3 other alternatives? Now you see, it have suggested 3 other alternatives. They are nothing but hourly weather data, city hourly forecast, and urban weather hourly. Whatever you prefer, you can use it and take it forward. In this case, I'll be actually naming it as city weather hourly. What name you prefer? In case if you go with some other name, feel free to leave a comment. Also, you can leave the feedback about Copilot chat using the comment section. Before going further and implement the end-to-end pipeline, let's continue working on design. Already we got physical data model, which is nothing but collection for weather data. I'll be naming it as city weather hourly. Now, when it comes to our jobs, we also need to keep track when the jobs are running, whether they are successful or not. Also, the bookmark checkpoint with respect to the last successful run or even failed run. That way, we should be able to catch up whenever we run next time. Let's get into the details. You will understand what I'm talking about. In this case, I'll ask Copilot chat itself to provide another data model or collection to keep track of bookmark of each and every job run. So here I'm asking, can you provide another collection to keep track of bookmark or checkpoint of my pipeline? Also keep in mind, when we use AI tools like Copilot, we need to make sure context is set appropriately. In this case, we haven't mentioned about our pipeline anywhere else. Hence, it is better for us to give additional details about the requirement of the overall project. Now I'm saying, in this case, I am planning to build end-to-end pipeline to consume data using REST APIs for T-2, which means today minus 2 days. This is a bit additional details with respect to the overall project scope. Now let's see what it have to say. Now you see, the pipeline name is nothing but weather data ingestion. Last run is nothing but 2024-06-21. Status is completed. Last processed city is nothing but this one. Last processed date is nothing but this one. Next run, then comments. I like all the attributes. In case if you don't want any of the attributes, you can skip those. And also if you wanted to add additional attributes, you can consider adding them. Let's also ask for suggestions for the name of this collection. Please suggest a name for this Mongo collection. Here the collection name is nothing but pipeline checkpoints. Typically, we also have the log of historical runs. This is only the master table where we'll have the details about the latest run. In case if you wanted to keep track of each and every run, you can come up with the additional collection. For that, you can actually ask Copilot chat itself saying, please come up with name and other details to keep track of all historical runs. Let's see what it have to say. The name is nothing but pipeline run history. I think you can use the same fields in it. Let's ask a follow-up question saying, don't you think I need additional attributes in this new collection to keep track of historical runs? Let's see what it have to say. Now you see it have pipeline name, run date, then start time, end time, status, processed cities, success count, failure count, errors, so on and so forth. This is how you should be able to keep track of all the historical runs when it comes to our pipeline where we are going to get the data from Meteo into MongoDB. Having these collections is very, very important for the robustness and reliability of our pipelines. That being said, let's take it forward and come up with the code to build the pipelines. In case if we have to add anything in the process, we'll make sure we add those as well. As we are ready with the data model and also as we are ready with the logic to get the data from Meteo using REST API, now it is time for us to go through the details about how to transform the REST API outcome into a form where it can be populated into the main collection. The main collection where we're going to populate the data is nothing but this one. It is city, weather, hourly. We also have two other collections to keep track of the jobs. First, we'll focus on transforming the data into format where it can be populated into the collection. When it comes to the collection structure, this is what we have come with using Copilot chat. Now, let's go to the terminal. Let's make sure we run the job again. I'm going to copy paste the outcome into the Copilot chat, and then I'll ask Copilot chat to come up with the logic to transform the data so that this data can be populated into the MongoDB in the desired structure. So let me copy paste outcome of one of the cities. This is related to one of the cities. Now it is copied. Again, we need to come up with the appropriate prompt so that we get the desired result. Now, please come up with suggestions about how to process the data as below to the format of MongoDB collection, which is nothing but, let me scroll up and confirm the name. The name of the collection is nothing but city, weather, hourly. City, weather, hourly. Below is the response of the REST API call to Meteo for one of the cities. Now, let me hit enter. It should remember the context. Based on the context, it should come up with the logic. You can see it is not only coming up with the logic, it is also providing the required explanation. Now let's scroll up. It is saying we need to extract city name. We have to prepare the document structure. We have to iterate over the hourly data. Then we have to format the data. It is actually giving the design here. It is asking us to initialize an empty list, weather data list. Then for each index in the range of hourly time data, create a document with the following structure. You can see the details here. Also, it haven't generated the logic, but it is asking us to come up with the logic. We'll ask Copilot chat itself to provide the logic. Can you provide the Python logic to do the same? Now let's see whether it will be able to generate the code or not. You can see it is generating the code here. So first the response is whatever response we got. Then city name, because the response doesn't have city name, but we know the city name as we fetch the data related to cities into the collection already. We'll be processing one city at a time. Hence we should be able to use that as the city name. Then it is actually providing the logic to populate into the MongoDB collection, but I'm not interested in populating data into MongoDB collection yet, because on top of populating this data, I also need to populate the other collections to keep track of job. But this logic is the one which I'm interested in. You can see here, it is actually converting the logic into the format which we are looking for. In this case, if you observe, it is not using Pandas. Let's check with the Copilot chat itself whether Pandas is suggested or this approach is suggested. Even this approach is not very complicated, but we'll confirm. Can you confirm which approach is better, using Python collections directly or Pandas? Now the response is generated. Let's go to the details here. It have compared both Python collections and Pandas, it have given pros as well as cons. Let's see the conclusion. The conclusion says for simple tasks or when working with small datasets where performance is not a critical concern, using Python's built-in collections can be more straightforward and lightweight. For complex data manipulation, it is suggesting Pandas. In the context of processing API responses for insertion into MongoDB, if the data transformation is straightforward and the dataset is not large, using Python collections directly is sufficient and simpler. However, it haven't concluded based on our use case. Let's check that as well. Here I am saying, can you confirm which approach is better for our task? Whether data from REST API to MongoDB, it is saying using Python collections directly is generally the better approach. It have even given the justification. You can go to the justification and confirm whether you wanted to use Pandas or collections. In this case, we'll be using collections itself because the logic is not very complicated. If you observe, Copilot chat can also be used to evaluate our design decisions to confirm whether we are using right approach or not. Now, we need to copy this. Let me copy this code. I have to go to app.py. Then I have to paste and then update the logic so that data is processed without much challenges. Also, we need to make sure the data is copied properly. Let me delete. Let me paste here. I need to make sure the code is indented properly. Let me make sure to hit tab by selecting this piece of code. We should not be having the imports here. Even though syntactically it works, it is not best practice. Let me clean these two lines. When it comes to response, we will be passing the weather API call response as argument to this. Hence, let me say weather data, and also let me make sure this is renamed as weather data. The reason why I am renaming it is because it might be used elsewhere in this function. If we rename here, everywhere it will be renamed. You can see here, it is automatically renamed. Now we can clean this up. We don't need, because the weather data is already passed as argument. We should not be creating weather data with empty dictionary again. That being said, when it comes to city name, we need to make sure we also pass the city name as argument. So let me also say city name here. We can remove these two lines also. At this time, we are not going to populate the data into MongoDB yet. Hence, let's clean up this as well. Also, we need to make sure these are cleaned up. Now, for each city, we not only have to fetch the data using REST API, we also need to process and convert it to a format which can be populated into the collection. For that purpose, we can actually say process weather data, then city of city, comma, weather data. Also, we need to make sure we move this piece of code to the main function, which is nothing but this one. We need to copy paste the weather data list here. Then we need to make sure the outcome is appended to weather data list in each iteration while processing data for each city. This should be added here. And here we are supposed to return. Let me say return document. However, it has to be outside the for loop. When I say it has to be outside the for loop, I am referring to this return statement. Also, after closer look, I have observed the code is not as per the expectations. When it comes to the data, it is supposed to be Python list. We can review here. Let me zoom in a little bit here. Now, let me scroll up. You can see that the collection should be populating the data in the form of list. You can see here. Or when it comes to JSON, this is known as array. So we need to have array for each city, for each date, which is not the case. Hence, we need to fix the issue in the code. When it comes to AI tools like Copilot chat or Copilot, this is quite common. We just need to review the code and fix. Let's get into the details about how to fix the code so that it works as per the expectations. Now, if you run this, it will not give us the desired results. We need to troubleshoot and take it forward. As I have identified the issue already, I am not going to run. I'll first fix and then run. As Copilot chat haven't generated the code as per the expectations, let's go ahead and fix the code. In case if you are not comfortable with the collections, make sure to refresh the collections and then come back here. We have a lot of free content on our YouTube channel. Feel free to look at the description. You can follow the link and take it forward. Even if you are going through this course in Udemy, we'll actually provide the link to our free course on YouTube. You can take it up and then you should be able to understand how to process data in collections. That being said, now let me scroll up here. First, I'll be moving this out. It doesn't make sense to have this within for loop. Now this piece of code is moved out of the for loop. We need to make sure this is indented properly. Now what we are supposed to do is we need to make sure even date is passed as argument here. Then we have to clean this up. We should not be having this here. However, I need this piece of code for my reference. Let me comment this out. Now let me initialize the empty list by name data here. In this case, I need to say data.append. Then I need to make sure whatever logic we have here is added. This is how it should be. Every hour we are creating one dict with hour, temperature, 2m, precipitation, rain, etc. Then we need to make sure we update the document with the data. For that purpose, we can say document of data equal to data. Then we can return the document. This is how we should be able to process the data as per the expectations. We can clean this up. It is not required anymore. Now, in each iteration, we need to make sure we pass all these details so that it works as per the expectations. Let me save this. Let me scroll down. Let me also go through the outcome once again. This is the actual outcome which you have seen earlier. On top of elevation, generation time, MS, hourly, where we have all the important data, we also have these details: latitude, longitude, time zone, etc. If you are interested in these, you can keep track of these as well, but I'm not interested in any of those. Hence, I'll be only picking the data from hourly. Now, let's go back here. In this case, we need to make sure we say weather data processed equal to process weather data blah blah blah. Let's copy this and paste here. This one will be appended to weather data list. However, on top of city weather data, we also need to pass the date. The way we can pass the date is like this. Now let's go to the read weather data logic. If you observe, when it comes to read weather data, we are specifying start date and end date here. They are hard coded. Now on top of city, we need to make sure we pass start date and end date as well here. So we are updating read weather data logic as well here. Let me say start date, then end date. Now it is time for us to add those two arguments also here. Let me say start date, then end date. Here I'll be hard coding these values for now. Let me say start date equal to 2024, then 06, then 25. Even with respect to end date, I'll be specifying the same value. Let me say end date equal to 2024, 06, 25. Otherwise, I'll be getting data for 2 days. Now, let me save this. Here also, we need to pass the date. I'll be using start date. Keep in mind, we'll be using the details from the job control tables to pass these as arguments. For now, we'll just pass the hard-coded values. As we are done with the code, it is time for us to validate to see if it is working as per the expectations or not. Before getting into the details related to validating, I would like to review the code once again. We have picked the code generated by Copilot chat. However, Copilot chat haven't generated the code accurately, but it have given the core logic. Based on our understanding, we have made required changes to process weather data after copy pasting the code generated by Populate chat. On top of this, we have also updated read weather data. Earlier start date and end date are hard coded here. Now we are accepting these as arguments, and then we are using this information to invoke the REST API when it comes to read weather data. Also, with respect to main function, we have added these two lines of code, and also we have updated this line so that everything works as per the expectations. Once we run this code, weather data list will have data in the format which can be populated into MongoDB as per the expectations. Let me make sure I clean this up and then let me make sure I print the outcome here, pprint weather data list. In case if you wanted to print for each city separately, you can actually have pprint statement here itself, or you can also iterate through the weather data list and then use pprint to print each element. In this case, I'll be printing everything at once. Hence, I'm using pprint weather data list immediately after the for loop. Now let me save this. Here I'm in the terminal. Keeping fingers crossed, let me say Python app.py to see if it works as per the expectations or not. Now you see it is working as per the expectations. So I can see the city, then data for each hour with respect to Johannesburg, which is nothing but the last city. Then we can also see the date. So the outcome is as per the expectations. We should be able to use this to populate into MongoDB. Let me highlight the record related to Johannesburg here. This entire record or document is related to Johannesburg. This is related to another city. Now I am selecting the record or document for the another city. In this case, this is for the London. Like that, we have data for 6 cities in this list which is printed here. As we have successfully come up with core logic related to processing the data, now it is time for us to come up with a logic to populate MongoDB. On top of populating the actual data, we also need to make sure the data related to jobs are populated into respective collections. Total, we have 4 collections. One is for city coordinates. Second one is primarily for the transactional data related to weather. Then we have 2 collections for jobs. One is to keep track of checkpoint or bookmark. The other one is to keep track of job history. We'll get into the details about how to come up with the logic to load the relevant data into relevant collections. Then you will understand how we typically build the end-to-end pipelines. As we are ready with the process logic, now it is time for us to come up with the load logic. We'll be populating all the elements in the list at once into MongoDB. If you want, you can also populate one record at a time, but from the performance perspective, you should always prefer bulk inserts rather than inserting individual record at a time. That being said, now let's get into load weather data. I'll be calling this outside the for loop. Hence, let me say load weather data here. I have to pass weather data list as argument to this. Now I need to make sure I accept weather data list here. Now let me remove pass here, and then let me come up with doc string saying populate data into MongoDB. Let me rephrase it here. Populate weather data list into MongoDB. Database is nothing but weather.db. It is correct. When it comes to collection, we can name it as weather data, but we wanted to pick the name which we have come up with using Copilot chat. The name is nothing but this one, city weather hourly. Let's make sure we use it. Here, let me say collection city weather hourly. That's it. Now we should be able to hit enter here. It will start auto-suggesting the code. If you are happy with that, you just hit tab to fill. Client is defined, then DB is defined with weather DB. Collection is defined with city weather hourly. Now collection.insert menu will take care of populating the entire weather data list into Mongo collection. Let me save this. Now let me also make sure I am invoking load weather data outside the for loop, which means we are going to populate the entire data at once into this collection called as city weather hourly. Here I am going to Mongo Compass and checking if there is a collection already with that name. As of now, there is no collection with that name. We only have city coordinates. I have refreshed. You can see it is not showing up any additional collections. Now let me go back here. Let me go to terminal. Let me say Python app.py. Let's see what happens. Now you can see it have ran even loading weather data here. We should be able to go to Mongo Compass here and then refresh. You see city weather hourly or hourly, and you should be able to see the records. And you can see data is nothing but array in this, and you can see details about each and every hour by expanding like this. This is how you should be able to take care of populating the data into Mongo collection. In this case, we are using insert many to populate data related to all the cities at once. So in this case, we are fetching data per city, then processing it. However, when it comes to populating the data, we are populating all the data at once. You can review the code once again to confirm that. With respect to reading data and processing the data, they are part of for loop. But with respect to loading the data, it is outside the for loop. That being said, let's also go through the details about how to manage if the data already exists in the collection. There are primarily two ways which can be used to manage data if it is already in the collection. One is delete and populate. Second one is upset or merge. Depending upon the use case, you have to make the decision and take it forward. In this case, we can just delete and insert. Let's get into the details about how to delete the data if it already exists and then populate. If data doesn't exist, we just have to populate. The reason why we have to do this is because as city and date are not part of key, there will be duplicates if you run this multiple times. Let me attempt to run this multiple times and see what happens. As of now, with respect to this Mongo collection, we have 6 records. You can see the details here. This 6 is nothing but total number of documents in this collection. That being said, now let me attempt running this once again. I'm saying python app.py. However, before running this once again, let me actually improvise on these print statements. Let me go to read data first. Here, let me say reading weather data for city and date, start date. In the similar manner, I would like to update the print statement in process weather data as well. Let me also update in load weather data. You can see that it is automatically suggesting based on the context. We don't need to type all these details explicitly. First, let me make sure I add F here. Then let me hit space. Now let me say loading weather data into MongoDB, len of weather data list records. I think this is more than enough. If you want, you can also pass the date because date is hard coded. Hence, we should be able to pass the date as well here just to make sure we print appropriately. So in this case, let me add one more argument, which is nothing but start date. Then let me update the print statement. Let me actually delete this. Now let me hit space. You can see it is saying for date, start date. This is enough. Now I have saved this. Let me go here. Earlier the messages are like this, which are not very meaningful. This time the messages will be meaningful. You can see here it is saying invoking main function, in main function, getting city coordinates, then reading weather data for Delhi, Dubai, Dallas, so on and so forth for date 2024 June 25th. Finally, loading weather data into MongoDB for date 2024 June 25th. This is how you should be able to even improvise your messages. Now if I go here and if I refresh, you see it have returned 12 records, which means we have duplicates. We should avoid this. We should not be populating the same data again and again. That is where either delete and insert or upset, which is also known as merge, comes into play. We'll get into those details very soon so that we understand how to deal with these kind of scenarios to avoid duplicates. As our current logic is inserting duplicates into Mongo collection, now let's get into the details about how to handle this. I'll be following a very simple design. It is more than enough for our use case. The simple design is nothing but delete the data before processing and then process and then write data back to MongoDB collection. Here, let me actually close this and then come up with additional function which says delete data from Mongo. Now, let me say def delete weather data. Let me autofill here. If you observe, it have generated the entire code at once, including docstring. I have just hit tab to fill the code here. Now the code to clean up based on a given date is ready. It is time for us to include this as well. I just have to say this, delete weather data start date. Now let me save this. Let me run this once again. Let's see what happens. In this case, if the data doesn't exist based on the condition using which we are attempting to delete, it will be ignored. If the data exists, then only it will delete. You can review the message here. It is saying deleting weather data from MongoDB for date 2024 June 25th. Now, if I go to Mongo Compass and then refresh this, it will only show 6 records. I have already refreshed once earlier, that's why it is actually showing 6 earlier as well. Now you can see 6 here. This is how you should be able to take care of deleting the data if it already exists before loading the data into Mongo collection. This is the core logic to read, process and load the data into Mongo collection. Now it is time for us to get into the details about how to populate the job control collections or tables. Let's review the details and then we'll take it forward. In this case, it have suggested 2 collections, or we have chatted with the Copilot chat and have come up with 2 collections. The 2 collection names are nothing but these. Let me scroll up. The first collection name is nothing but job checkpoints or something, or pipeline checkpoints, you can see here. Then the second collection is named as pipeline run history. The structure of pipeline checkpoints is this. We'll be having pipeline name, then last run, then status, then last processed city, last processed date, next run comments. Then we have pipeline run history, where we are keeping track of each and every city to see whether the data is successfully populated or not in each and every iteration. Let's get into the details so that you understand the relevance of these job control tables or collections as well. In traditional RDBMS, we call these as tables. In MongoDB, we call these as collections. As we are done with core logic to populate weather data from REST APIs into Mongo collection, now let's get into the details related to populating job control collections or tables. First, I'll focus on checkpoint, then I'll get into the details related to run history. This is the collection with respect to checkpoint. Let me copy this. Let me go here and let me add one more function saying def update checkpoint. I'll be adding the function after delete here. Let me say def update pipeline checkpoint. Then let me paste this here. Let me make sure I indent properly. Also, let me make sure I comment this out. Now let me come up with a docstring saying update pipeline checkpoint details in MongoDB. When it comes to collection name, it is supposed to be this one. I think it is pipeline checkpoints, but I'll be copy pasting it. You can see here it is nothing but pipeline checkpoints. Now it is added here, pipeline checkpoints. Keep in mind there should be only one record in this. The record should have the pipeline name like this. Then we need to have other details such as last run status, last processed city, last processed date, next run comments, etc. To update all this information, we need to make sure we pass weather data list, which is nothing but this one. So let me copy this and let me paste here. Also, with respect to this first line in this docstring, let me say insert or update. Now let me save this. Now let me hit enter. Let me hit enter once again. Let me add this print statement which will print saying updating pipeline checkpoint details. Let me also say start date here so that it actually refers to start date based on which it is doing. Let me say F, then let me actually say for date start date. Then let me hit enter. It is attempting to create client object, then database object, then collection object. The collection is nothing but pipeline checkpoints. Now let me make sure we come up with the logic. It is checking whether there is a record already. You can see the comment here. It is checking if pipeline checkpoint exists for the given date, which is not correct. There should be only one record. Let me actually update this by saying pipeline name. The name of the pipeline is nothing but weather data ingestion. It has to be string. Let me put this in double quotes. Now let me hit enter. It is saying if result doesn't exist, then it is updating. Otherwise, it is inserting. Now let me hit tab to autofill. Let me save this. This is how you should be able to come up with the logic. When it comes to next run, the next run is supposed to be the incremented by 1 day. So in this case, if we run for 2024 June 23rd, it is supposed to be 2024 June 24th. If the job is run for 2024 June 24th, then it is supposed to be 2024 June 25th. So let's also add logic here. In this case, I'm saying next run should be incremented by 1 day based on last processed date or start date. In this case, it is nothing but start date. Now let me hit enter. You see, it is not auto suggesting. If it is not auto suggesting, all you need to do is you select this entire line because we have the required prompt in this. Then we have to hit Ctrl I, then paste. I have copied the entire line and pasted here. Then let's click on this. It is asking us to import date time and time delta at the beginning. We can click on accept. It is added. Then it is asking us to come up with a logic like this. We can hit accept here. Yeah, we have accepted these suggestions. Let's also make sure we review the changes that are made. In the beginning, we have included this import statement. The import statement is nothing but from datetime import datetime and delta. On top of this, we also have if condition as part of update pipeline checkpoint. The if condition is nothing but this one. So it is checking whether last processed date is there in result or not. If it exists, then it is fetching the details with respect to last processed date, and then it is being converted to Python date. Now last processed date will have Python date of whatever we have in the collection. Then the last processed date is being incremented by 1. This logic will take care of incrementing the last processed date by 1. The value will be assigned to next run. If last processed date doesn't exist in result, then it is just using start date as reference and it is being incremented by 1. You can also check next run is set to standard string formatted date here so that it can be populated into Mongo collection without any issues. So we have the required logic to update the checkpoint. All we need to do is we clean up this. Let me clean up this. This I have pasted to just come up with the code. It doesn't make sense to have it as comment in the code. We can also clean this up, or we can actually remove this one line and then keep it like this. Now we should be able to scroll down and then we can say update pipeline checkpoint with weather data list and start date. Now as the changes are ready, it is time for us to validate. Let's make sure we go to the terminal, then say python app.py. Let's see what happens. This time we should see additional collection in Mongo. It is nothing but pipeline checkpoint or pipeline checkpoints. However, it have failed. It is complaining on result, which means when it comes to the if condition, it is not placed properly. Let's go back to the update pipeline checkpoint. Here we have the logic to check for last processed date in the result even before we established connection to the Mongo collection, which is not appropriate. We need to move this entire logic to here. This is where it is supposed to be. Okay. Also, we need to say if result and last processed date in result. This means if result exists, then only it will check for last processed date in result. Otherwise, it will directly go to else and then it will compute next run based on start date. Let me also make sure this comment is indented properly. Now we should be able to run this and it should work without much challenges. However, if we face any challenges, we'll fix and we'll move forward. Now let's see what happens. It is processing the data. Now everything have worked as per the expectations. We can confirm by going to Mongo Compass here. First, let's refresh. We should see one more collection. It is nothing but pipeline checkpoints. Let's see the contents in pipeline checkpoints. You can see the details here. Weather data ingestion, then last run is 2024 June 25th, which is not correct. Actually, the last run is supposed to be based on system date. Then status is completed. Last processed city is nothing but Johannesburg. Last processed date is nothing but 2024 June 25th. Next run is hard-coded here, or I don't know why it is giving 2024 June 23rd. Again, this has to be fixed. And then we have the comment. Now let's go back to this one and fix the issues. We have two issues. One, when it comes to last run, it is based on start date, which is not correct. Here last date should be based on the today's date. We can actually say date time, then now, then strf time percentage y blah blah blah. I also wanted to have the timestamp. Let me include timestamp as well. That way we will know when this is actually run. It is more meaningful to have timestamp as well when it comes to last run. On top of it, we also have an issue with the next run. You can see it is hard coded. We need to fix this as well. This is supposed to be next run, not the hard coded value. On top of updating here, while invoking update one, we also need to update in insert one. When it comes to this one, it is supposed to be next run. Let me say next run here. Also, when it comes to last run, it is supposed to be based on today's date. You can see it have auto suggested based on whatever logic we have here. So it will remember the context and then it will keep suggesting to us so that we don't miss any of the important aspects while coming up with the code. So it covers a lot of our gaps. When I say it, I am talking about Copilot. Now let me save this. The changes are done. First, let me make sure I delete this document. Now the document is deleted. As soon as the document is deleted, we should be able to validate. However, to confirm whether it is deleted or not, let me click on this to refresh. Now you can see there is no data in this collection called as pipeline checkpoints, which means it is successfully deleted. We should be able to go to terminal here and then run it once again. Let's wait until it is fully run. Then we'll refresh to see if data is as per the expectations or not in pipeline checkpoints. Now let me refresh. You can see the data here. It is as per the expectations. You can review and confirm everything is as per the expectations, whether it is last run or last processed date or next run, it is as per the logic. Last run is nothing but current timestamp when the job is successfully run, then status is nothing but completed. Last processed city is last city within our data. We have 6 cities. Johannesburg is the last one. That's why we are seeing Johannesburg here. When it comes to last processed date, this is the date based on which the data is processed in the last successful run. Next run is incremented by 1 based on last processed date. Then we also have comments. This is how you should be able to come up with a logic to populate this very important job control collection or table. The name of the table or collection is nothing but pipeline checkpoints. Now it is also time for us to get into the details about how to populate job run history. Also, we need to understand details about how to catch up. For example, we might wanted to use June 1st as the starting point. We have to catch up until T-2 because in the subsequent runs, we always process T-2. We'll also get into the details about taking care of baseline loads so that we catch up with our load. That's when all the dots will be connected. So far, we have almost completed 70% of the pipeline logic, but still there are 30% of the tasks pending. We'll get into those 30% tasks as well. As we are able to successfully populate pipeline checkpoints collection, now it is time for us to populate another collection called as pipeline run history or job history. Whatever is the collection name, we'll pick that and then we'll take it forward. It is relatively simple when it comes to populating this additional collection. It is history. Hence, we'll have entry for each run. Whether it is successful or failure, we'll have the details. Let's get into the details so that you understand what I'm talking about here. In this case, I'll be picking up the collection name first. Let me go to my chart. Let me scroll up here. The collection name is nothing but pipeline run history or job run history. Let me see. It is nothing but pipeline run history. Let me copy this part first. In this case, it has some sample data. We'll use this as reference to come up with the code using Copilot in our main program. Now let me go here. Let me zoom out a little bit. Now let me scroll down and then say def add pipeline run history. Now let me paste the copied JSON here, or it can also be considered as dict. We need to make sure it is formatted properly. On top of it, I need to make sure this is commented out. I have copy pasted only for my reference so that the code can be generated quickly. As it is commented out, now let me hit enter. Let's see what it have to say. It is saying pass. Let me hit enter once again. Let me actually update the docstring here. Let me say add pipeline run history details in MongoDB. Database is nothing but weatherdb. Collection is nothing but pipeline run history. Now let me save this. When it comes to this one, it is supposed to take weather data list as argument, probably start date also. Let's copy this. Now let's hit enter and let's see what it will come up with. Now I don't want pass. Let me hit enter. It have come up with this print statement. Let me accept it. Now let me go to the next line. Here we need to come up with a logic to create a client object followed by DB object, then collection object. It is not coming up with any logic here. We just have to hit Ctrl I, then ask for it. Come up with logic to populate pipeline run history based on the dict or JSON provided in this function. Once you hit enter with this prompt, you can wait until the code is generated. You can review the code and take it forward, or you can also accept and then review. Let me accept and then review. Here it is initializing something called as pipeline run data. You can see here it have pipeline name, run date, start time, end time, status, so on and so forth. In this case, we need to make sure start time and end time are appropriately populated. Start time and end time are getting populated with the same values, which is not correct. We will address it very soon. Here we need to fix the start time part. Let me actually say job run start time here. This will be third argument for this. In this case, I'll be using job run start time here. Then end time is nothing but the current timestamp. Then status can be completed. Processed cities is empty list. Success count is 0. Failure count is 0. Errors is also empty. I'll not be getting into the details about failure count and errors, but in actual pipelines, we'll even handle that by using exceptions appropriately. For now, let's get into the other details where processed cities and success count are updated. You can review this for loop to understand how processed cities and success count are updated. We can also use the success count as reference. We can subtract from 24 and then we can add it to failure count. However, the more appropriate way is to deal with exceptions, which we will not be covering. In case if you wanted to get the explanation with Copilot, you can also get explanation. You can right click on this, then go to Copilot and then you can click on explain this. It will actually take care of explaining this for loop for you, but it is very straightforward. Hence, I am not going through the details which are provided here. It is just extracting the city from each record and then adding start date so that for each and every city, we capture city as well as start date. Now, let me close this. Let me save this. Let me make sure I also add one more function call here, which is nothing but add pipeline run history. In this case, you see it have automatically filled the start time, but this is not correct. We wanted to use more appropriate value. In this case, it is supposed to be like this. Let me use the same variable here. Let me also clean this up. I don't want this anymore. Hence, I am cleaning this up. Now, I wanted to use same name, job run start time. Let me go here and then let me add it here. Job run start time equal to date time. Then now STRF time, then including timestamp, I am capturing the information which is nothing but current timestamp. As soon as the main function is invoked, this will be defined. This is what we are supposed to use here, so that we capture the actual start time of the job run in job run history or pipeline run history. Now let me save this. Let me go to terminal. Let me run application by using python app.py. Let's wait until it is fully run. Then we will review the details in Mongo. You can see it is saying adding pipeline run history details for date at the end. Let's go back here. Let's refresh. You can see pipeline run history. Now you can see the details with respect to all the attributes in this collection, except for failure count and errors, of course. So we have pipeline name, run date, start time. It is started at 6:10. You can see here. Then it have ended at again 6:10. But when it comes to seconds, I think this I have to fix. The seconds part is not correct. Then we have status, then processed cities. Oh, second spot is also correct. It just took 4 seconds to complete. So it is 17 and it is 21. I think there's an issue with respect to time zone. It is displaying Z or Z here. You can ignore for now. If you want, you can fix as well. Now, when it comes to processed cities, we have 6 elements. It is of type array. Each element have the city and also the date for which data is processed. Then when it comes to success count, it is 6. For each and every city, the data is successfully populated into the collection. Hence, it has 6 when it comes to success count. You can also capture success count at our level also if you want. But in this case, we don't want to. We just wanted to get total success count, which is correct here. If there are any failures using exceptions, we should be able to handle it and we can actually capture the failure count as well. For now, this will not fail that easily. Hence, I'm not getting into the details. But in your projects, if the requirements suggest you to handle exceptions and capture the failure count, you need to take care. That being said, this is how you can actually populate the run history. However, even though the logic is almost complete, still we are not using the next run which is populated in the last run in checkpoint table to run next time. Start date and end date are hard coded. We need to fix this so that we complete the development of this pipeline. Let's get into the details about using next run as reference to run next time. As we are almost done with our pipeline, it is time for us to make sure start date and end date are based on the checkpoint. Let's review the checkpoint and then we'll take it forward. To review the checkpoint, I'm going to this pipeline checkpoints. It have a field by name next run. It is nothing but 2024 June 26th. Next time when we attempt to run, it is supposed to be used as reference and then it should be able to fetch the data from Open Meteo using REST API calls. First, let me delete this. I'm deleting the document from the checkpoint collection. Also, let me clean up pipeline run history. To avoid any confusion, let me also clean up city weather hourly. Let me say delete. Let me click on delete 6 documents. Then make sure to click on refresh so that it is refreshed to confirm data is successfully deleted or not. As of now, all the 3 collections are cleaned up. Only city coordinates have data. It have data for 6 cities. Now let me go back here. I will change the start date and end date to June 1st and run. Let me change this to June 1st. Now let me run this by saying python app.py. This time we are populating data for June 1st. Once it is populated, then I'll make the required changes to use next run to successfully run for the next time. Now data is processed. You can actually review by going to city weather hourly. You should see the data related to 2024 June 1st. Now let's go to the app.py again. This time we'll actually use next run within checkpoint table or checkpoint collection. You see there is something called as next run. As of now, with respect to pipeline checkpoints, the next run is nothing but 2024 June 2nd. This needs to be used when we run next time so that the data related to 2024 June 2nd is fetched and populated into the city weather hourly collection. That being said, let me add one more function here. The function name is nothing but get checkpoint def get pipeline checkpoint. You see it have auto suggested the code. Let's go to the details here. It is actually creating the client object here, then DB object, then collection, everything looks good. Then result equal to collection find one, blah, blah, blah. It is returning the complete result. However, instead of returning the complete result, I wanted to return next run, or you can also use this information to extract the next run as part of the main function. We'll take that approach. Let me actually go here. Wherever we are populating or we are assigning dates to start date and end date, we'll be invoking that function. The function is nothing but get pipeline checkpoint. We need to make sure it is assigned to something. So let me say checkpoint equal to get pipeline checkpoint. No arguments at all. Just invoke the function without any arguments because there are no parameters when it comes to this function. Now when it comes to start date, I would like to use checkpoint then next run. Same is the case with end date. It will be checkpoint next run. As of now, the pipeline checkpoints is not empty because we have hard-coded 2024 June 1st and run successfully. Hence, there is one document in that collection. You can review here. This is what we are referring to. Hence, this will work. However, if the pipeline checkpoint doesn't have any entry in it, then it will fail. The way you can handle it is like this. You can add additional condition by saying if checkpoint is not none, then only set start date and end date using checkpoint next run. Else, you can say start date equal to 2024-06-01 and end date also equal to 2024 June 1st or 0601. Now let's save this. Now let's go to terminal here and then run the application using Python app.py. Before running, again I am cleaning up everything. The way I can clean up is like this. I can say delete here, then click on delete one document. In the similar fashion, I would like to delete run history. Also, I would like to delete city weather hourly collection. Let me click on delete here. Let me click on delete 6 documents and delete all the documents. Let's make sure we refresh and confirm if everything is deleted or not. In all 3 collections, all the data is deleted. Now let's run this once again. I'll be running 3 times and we will see what is going on. This is the first attempt and we are populating data related to 2024 June 1st. First, let's go to city weather hourly. You should be able to see 6 documents. You can see here there are 6 documents. You can also go to the data here. Then pipeline checkpoints will have only one document. You can see the one document. Next run is nothing but 2024 June 2nd. Then pipeline run history have one document. It have all the details with respect to 2024 June 1st. You can expand this and confirm whether date is 2024 June 1st or not for each of these cities. Now let's attempt to run this once again. This time it will run for 2024 June 2nd. You can see it is running for 2024 June 2nd. Now it is successfully run. Let's go here once again. This time let me first refresh pipeline checkpoints. You can see here last processed date is 2024 June 2nd. However, next run is still 2024 June 2nd, which is not correct. It is supposed to be incremented by 1. For some reason, it didn't work. But let's check the pipeline run history. You see there are 2 documents in this. Let me see which one is first one and which one is second one. I think this is first one and this is the second one. You can review the dates for each of these cities. It is nothing but 2024 June 2nd. Let's also go to city weather hourly. We should be seeing 12 documents. You can see all the 12 documents. The first 6 are related to 2024 June 1st. Then the next 6 are related to 2024 June 2nd. However, there is a bug in this. When it comes to pipeline checkpoints, the next run is still pointing to 2024 June 2nd, which is not correct. So which function we need to review? The function which we need to review is nothing but update pipeline checkpoint. Let's make sure we go to that function. We can use control and then click on that function to go to that. You can click on go to definition here. Now let's scroll down. This is the logic which is not working. The problem is with this if condition. Here we are using last processed date as reference to increment by 1. When we run for the first time, as part of the checkpoint table, last processed date is nothing but 2024 June 1st. Using that, it is incremented by 1 to assign to next run. It is not correct. Instead of using last processed date here, we are supposed to use next run itself. So let me say last next run here, last next run. Then let me specify next run here. Here also I should be using last next run. Now let me save this. Let me clean up everything. Then I'll run twice or thrice again to confirm whether everything is working as per the expectations or not. First, I am deleting from city weather hourly. Then I'll be deleting from pipeline checkpoints. Then I'll be deleting from pipeline run history. Now all the 3 collections are cleaned up. Let me refresh to confirm whether it is successfully cleaned up or not. You can see it is successfully cleaned up. Now it is time for us to run this once again. Let's see what happens. So it is running for the first time. It have run successfully. Let's make sure we review data in all 3 collections, especially city weather hourly and pipeline checkpoints, it is not important to review pipeline run history because there are no issues with respect to that. With respect to city weather hourly, you can see the 6 documents in the collection. When it comes to pipeline checkpoints, you can see the only one document in the collection. Last processed date is nothing but 2024 June 1st. Next run is nothing but 2024 June 2nd. Now let me run once again. Let's see what happens. It have ran successfully. Let's go to city weather hourly. You can see 12 documents. Let's check pipeline checkpoints. You can see next run as 2024 June 3rd as per the expectations. When it comes to last processed date, it is nothing but 2024 June 2nd. It means it is working as per the expectations. Now let me run once again. This time it is running for 2024 June 3rd. Let's review the checkpoint details once again here. You can see last processed date is nothing but 2024 June 3rd. When it comes to next run, it is as per the expectations. This time it is nothing but 2024 June 4th. It took a bit of time because we ran into bug when we start using next run as reference to run subsequent ones. We fixed that bug and validated. Everything is working as per the expectations. The pipeline is ready. However, we need to make sure we catch up starting from baseline date. That is called as baseline load. We'll get into the details about what is baseline load and also how to improvise to take care of baseline load within this pipeline itself. I understand we are having a marathon run here. However, don't give up. Make sure you get into the details with respect to baseline load also. Soon we'll be concluding this course once we go to the details related to baseline load. As we are able to successfully populate pipeline checkpoints collection, now it is time for us to populate another collection called as pipeline run history or job history. Whatever is the collection name, we'll pick that and then we'll take it forward. It is relatively simple when it comes to populating this additional collection. It is history. Hence, we'll have entry for each run. Whether it is successful or failure, we'll have the details. Let's get into the details so that you understand what I'm talking about here. In this case, I'll be picking up the collection name first. Let me go to my chart. Let me scroll up here. The collection name is nothing but pipeline run history or job run history. Let me see. It is nothing but pipeline run history. Let me copy this part first. In this case, it has some sample data. We'll use this as reference to come up with the code using Copilot in our main program. Now let me go here. Let me zoom out a little bit. Now let me scroll down and then say def add pipeline run history. Now let me paste the copied JSON here, or it can also be considered as dict. We need to make sure it is formatted properly. On top of it, I need to make sure this is commented out. I have copy pasted only for my reference so that the code can be generated quickly. As it is commented out, now let me hit enter. Let's see what it have to say. It is saying pass. Let me hit enter once again. Let me actually update the doc string here. Let me say add pipeline run history details in MongoDB. Database is nothing but weather.db. Collection is nothing but pipeline run history. Now let me save this. When it comes to this one, it is supposed to take weather data list as argument, probably start date also. Let's copy this. Now let's hit enter and let's see what it will come up with. Now I don't want pass. Let me hit enter. It have come up with this print statement. Let me accept it. Now let me go to the next line. Here we need to come up with a logic to create a client object followed by DB object, then collection object. It is not coming up with any logic here. We just have to hit Ctrl I, then ask for it. Come up with logic to populate pipeline run history based on the dict or JSON provided in this function. Once you hit enter with this prompt, you can wait until the code is generated. You can review the code and take it forward, or you can also accept and then review. Let me accept and then review. Here it is initializing something called as pipeline run data. You can see here it have pipeline name, run date, start time, end time, status, so on and so forth. In this case, we need to make sure start time and end time are appropriately populated. Start time and end time are getting populated with the same values, which is not correct. We will address it very soon. Here we need to fix the start time part. Let me actually say job run start time here. This will be third argument for this. In this case, I'll be using job run start time here. Then end time is nothing but the current timestamp. Then status can be completed. Processed cities is empty list. Success count is 0. Failure count is 0. Errors is also empty. I'll not be getting into the details about failure count and errors, but in actual pipelines, we'll even handle that by using exceptions appropriately. For now, let's get into the other details where processed cities and success count are updated. You can review this for loop to understand how processed cities and success count are updated. We can also use the success count as reference. We can subtract from 24 and then we can add it to failure count. However, the more appropriate way is to deal with exceptions, which we will not be covering. In case if you wanted to get the explanation with Copilot, you can also get explanation. You can right click on this, then go to Copilot, and then you can click on explain this. It will actually take care of explaining this for loop for you, but it is very straightforward. Hence, I'm not going through the details which are provided here. It is just extracting the city from each record and then adding start date so that for each and every city, we capture city as well as start date. Now, let me close this. Let me save this. Let me make sure I also add one more function call here, which is nothing but add pipeline run history. In this case, you see it have automatically filled the start time, but this is not correct. We wanted to use more appropriate value. In this case, it is supposed to be like this. Let me use the same variable here. Let me also clean this up. I don't want this anymore. Hence, I'm cleaning this up. Now, I wanted to use same name, job run start time. Let me go here and then let me add it here. Job run start time equal to date time. Then now STRF time, then including timestamp, I'm capturing the information which is nothing but current timestamp. As soon as the main function is invoked, this will be defined. This is what we are supposed to use here, so that we capture the actual start time of the job run in job run history or pipeline run history. Now let me save this. Let me go to terminal. Let me run application by using python app.py. Let's wait until it is fully run. Then we will review the details in Mongo. You can see it is saying adding pipeline run history details for date at the end. Let's go back here. Let's refresh. You can see pipeline run history. Now you can see the details with respect to all the attributes in this collection, except for failure count and errors, of course. So we have pipeline name, run date, start time. It is started at 6:10. You can see here. Then it have ended at again 6:10. But when it comes to seconds, I think this I have to fix. The seconds part is not correct. Then we have status, then processed cities. Oh, seconds part is also correct. It just took 4 seconds to complete. So it is 17 and it is 21. I think there's an issue with respect to time zone. It is displaying Z or Z here. You can ignore for now. If you want, you can fix as well. Now, when it comes to processed cities, we have 6 elements. It is of type array. Each element have the city and also the date for which data is processed. Then when it comes to success count, it is 6. For each and every city, the data is successfully populated into the collection. Hence, it has 6 when it comes to success count. You can also capture success count at our level also if you want. But in this case, we don't want to. We just wanted to get total success count, which is correct here. If there are any failures using exceptions, we should be able to handle it and we can actually capture the failure count as well. For now, this will not fail that easily. Hence, I'm not getting into the details. But in your projects, if the requirements suggest you to handle exceptions and capture the failure count, you need to take care. That being said, this is how you can actually populate the run history. However, even though the logic is almost complete, still we are not using the next run which is populated in the last run in checkpoint table to run next time. Start date and end date are hard-coded. We need to fix this so that we complete the development of this pipeline. Let's get into the details about using next run as reference to run next time. As we are ready with the core baseline load logic, now it is time for us to improvise our main function so that we have choice between baseline load versus daily load. The daily load should be default, but whenever we want to run baseline load, we should be able to run without much challenges. The way we can implement it is by using arguments to the program, or we can use environment variables as well. I'll be using environment variable approach. If you wanted to pass as argument, you can pass as argument. You can also define external properties and drive the logic using external properties. Either of the approaches will work and are widely used. That being said, already we have imported OS at the beginning. You can scroll up and check. You can see the import OS here. Now let's make sure we scroll down completely. As we scroll down here, let's make sure we define additional variable saying run flag equal to os.getEnv run flag. We can say daily by default, otherwise it has to be baseline. If run flag equal to baseline, then you have to invoke load baseline data, else you can invoke weather data pipeline. Even if you don't pass anything, weather data pipeline will be automatically be invoked. However, even after running load baseline data, it might end up running this. We don't want to do it. Hence, we'll be saying else here. Else, if run flag is not baseline, then it has to invoke weather data pipeline. Now, let's save this. In this case, we need to make sure we set this environment variable to run baseline data. Let me click on this. Now, let me say export. We are using Windows here, hence we have to use $env. Let's first check the value of run underscore flag. I think the environment variable name is nothing but run underscore flag. Hence I have to say run underscore flag like this. If you are using Mac, you can use the echo, then $run underscore flag to get the value of run underscore flag. If it is Windows, you have to use this approach. Now, to set this to a specific value, you have to use $env colon run underscore flag, then space, then equal to, then space. Then you have to specify the string in double quotes. Let me say baseline. If you are using Mac, you just have to say export, then run underscore flag, then equal to. You should not be having spaces around equal to when it comes to Mac or even Linux. Then you can actually specify baseline in double quotes or directly like this. This is the approach which you are supposed to follow in Mac or Linux. But when it comes to Windows, this is the approach which you need to follow. To validate on Mac or Linux, you have to use echo, then $, then environment variable like this. But with Windows, the command is nothing but $env, then colon run underscore flag. You can see it is nothing but baseline. Once this environment variable is set up, then we can say Python app.py, then hit enter. It will start processing the data starting from June 1st. It will catch up all the way till June 25th because we wanted to process data up to T-2. You can see the data is being processed automatically for us. We'll be catching up very soon. Let us wait until this is fully run, then we will validate to see if the data is actually populated into MongoDB collections as per the expectations or not. It is almost caught up. Keeping fingers crossed, I am waiting for 25th of June to see if it will break automatically or not. We are already at 2024 June 24th. Now we are at 2024 June 25th. Soon it should break. You can see it have broke at 2024 June 26th. Now, if you rerun this again, because we have the logic to clean up everything, it will clean up everything and it will take care of baseline load for us. If you want, you can try again and then see whether it is working as per the expectations or not. The reason why I am going to run once again is I wanted to test that scenario as well, whether data will be reset or not whenever we attempt to perform the baseline load. Let me hit up arrow once and then run again. Let's keep fingers crossed. However, it have exited prematurely. It haven't taken care of the baseline load. It means the delete functionality didn't work as per the expectations. We need to fix it. Now, let's go here. The reason why it haven't worked is because we are only cleaning up city weather hourly. We are not cleaning up other collections. That's why it is not processing the data for us. Let's see what we have in collections here. I'm going to city weather hourly. As part of city weather hourly, there is no data. But when I go to pipeline checkpoints, still there is one record, and the next run in that one record is saying 2024 June 26th, which is not correct. That's why it haven't run as per the expectations. The way we can address this is we can also delete the other collection and then we can take it forward. When I say delete other collection, I'm talking about deleting the data in other collection. Let me actually say checkpoint collection equal to db pipeline checkpoints, then checkpoint collection delete many. Let's save this. This time it should work without much challenges. You can see it have started processing data from 2024 June 1st. If you observe, validating all test case scenarios is very, very important to build robust and reliable pipelines. Otherwise, we'll start hitting surprises once the pipelines are deployed in UAT or production. Let's wait until the data is fully loaded. We will review and then we'll take it forward. Now you can see even second time it have run without any issues. You can run this pipeline as many times as you want. If it is baseline, it will just delete the data and reload. However, I wanted to validate the daily load as well. For that purpose, I just have to set the run flag to daily. Let me say daily. As it is already caught up, even with respect to daily, it will not run. It will just exit the pipeline. However, the data will be intact in the collections. You can look at city weather hourly. You see there are 150 records because it have processed for 25 days. For each day there are 6 records. Hence you can see 150 records are documents. When it comes to pipeline checkpoints, you can check the next run. It is nothing but 2024 June 26th. The last processed date is nothing but 2024 June 25th, which is T-2. Today is 2024 June 27th. When this is run tomorrow, it will attempt to process the data for 2024 June 26th. That being said, we are almost done with respect to our pipeline. We have even taken care of baseline load. However, I would like to cover few important concepts related to scheduling and then I'll conclude the course. Before going on to the scheduling, I also wanted to emphasize on creating more and more content like this. In case if you wanted to get notified, feel free to subscribe and also hit on bell icon. You'll be notified whenever we upload the content. Also leave comments about what further you wanted to learn. Whether you wanted to learn performance tuning with respect to MongoDB, orchestrating pipelines using Airflow, or building REST APIs using Python-based frameworks such as Fast API, or anything related to cloud platforms such as AWS, Azure, GCP, etc., or any other thing with respect to MongoDB, just add comment. I will review the details. If at all I can take care of it, I'll definitely take care of it. That being said, I hope you are enjoying the course so far. If yes, make sure to hit on like button. Also provide the feedback in comments and also feel free to share with your friends. As we are ready with the core baseline load logic, now it is time for us to improvise our main function so that we have choice between baseline load versus daily load. The daily load should be default, but whenever we want to run baseline load, we should be able to run without much challenges. The way we can implement it is by using arguments to the program, or we can use environment variables as well. I'll be using environment variable approach. If you wanted to pass as argument, you can pass as argument. You can also define external properties and drive the logic using external properties. Either of the approaches will work and are widely used. That being said, already we have imported OS at the beginning. You can scroll up and check. You can see the import OS here. Now let's make sure we scroll down completely. As we scroll down here, let's make sure we define additional variable saying run flag equal to os.getEnv run flag. We can say daily by default. Otherwise, it has to be baseline. If run flag equal to baseline, then you have to invoke load baseline data. Else, you can invoke weather data pipeline. Even if you don't pass anything, weather data pipeline will be automatically be invoked. However, even after running load baseline data, it might end up running this. We don't want to do it. Hence, we'll be saying else here. Else, if run flag is not baseline, then it has to invoke weather data pipeline. Now, let's save this. In this case, we need to make sure we set this environment variable to run baseline data. Let me click on this. Now, let me say export. We are using Windows here, hence we have to use $env. Let's first check the value of run underscore flag. I think the environment variable name is nothing but run underscore flag. Hence, I have to say run underscore flag like this. If you are using Mac, you can use echo, then $run underscore flag to get the value of run underscore flag. If it is Windows, you have to use this approach. Now, to set this to a specific value, you have to use $env colon run underscore flag, then space, then equal to, then space. Then you have to specify the string in double quotes. Let me say baseline. If you are using Mac, you just have to say export, then run underscore flag, then equal to. You should not be having spaces around equal to when it comes to Mac or even Linux. Then you can actually specify baseline in double quotes or directly like this. This is the approach which you are supposed to follow in Mac or Linux. But when it comes to Windows, this is the approach which you need to follow. To validate on Mac or Linux, you have to use echo, then $, then environment variable like this. But with Windows, the command is nothing but $env, then colon run underscore flag. You can see it is nothing but baseline. Once this environment variable is set up, then we can say Python app.py, then hit enter. It will start processing the data starting from June 1st. It will catch up all the way till June 25th because we wanted to process data up to T-2. You can see the data is being processed automatically for us. We'll be catching up very soon. Let us wait until this is fully run, then we will validate to see if the data is actually populated into MongoDB collections as per the expectations or not. It is almost caught up. Keeping fingers crossed, I am waiting for 25th of June to see if it will break automatically or not. We are already at 2024 June 24th. Now we are at 2024 June 25th. Soon it should break. You can see it have broke at 2024 June 26th. Now, if you rerun this again, because we have the logic to clean up everything, it will clean up everything and it will take care of baseline load for us. If you want, you can try again and then see whether it is working as per the expectations or not. The reason why I am going to run once again is I wanted to test that scenario as well, whether data will be reset or not whenever we attempt to perform the baseline load. Let me hit up arrow once and then run again. Let's keep fingers crossed. However, it have exited prematurely. It haven't taken care of the baseline load. It means the delete functionality didn't work as per the expectations. We need to fix it. Now, let's go here. The reason why it haven't worked is because we are only cleaning up city weather hourly. We are not cleaning up other collections. That's why it is not processing the data for us. Let's see what we have in collections here. I'm going to city weather hourly. As part of city weather hourly, there is no data. But when I go to pipeline checkpoints, still there is one record. And the next run in that one record is saying 2024 June 26th, which is not correct. That's why it haven't run as per the expectations. The way we can address this is we can also delete the other collection and then we can take it forward. When I say delete other collection, I'm talking about deleting the data in other collection. Let me actually say checkpoint collection equal to db pipeline checkpoints, then checkpoint collection delete many. Let's save this. This time it should work without much challenges. You can see it have started processing data from 2024 June 1st. If you observe, validating all test case scenarios is very, very important to build robust and reliable pipelines. Otherwise, we'll start hitting surprises once the pipelines are deployed in UAT or production. Let's wait until the data is fully loaded. We will review and then we'll take it forward. Now you can see even second time it have run without any issues. You can run this pipeline as many times as you want. If it is baseline, it will just delete the data and reload. However, I wanted to validate the daily load as well. For that purpose, I just have to set the run flag to daily. Let me say daily. As it is already caught up, even with respect to daily, it will not run. It will just exit the pipeline. However, the data will be intact in the collections. You can look at city weather hourly. You see there are 150 records because it have processed for 25 days. For each day there are 6 records. Hence you can see 150 records are documents. When it comes to pipeline checkpoints, you can check the next run. It is nothing but 2024 June 26th. The last processed date is nothing but 2024 June 25th, which is T-2. Today is 2024 June 27th. When this is run tomorrow, it will attempt to process the data for 2024 June 26th. That being said, we are almost done with respect to our pipeline. We have even taken care of baseline load. However, I would like to cover few important concepts related to scheduling, and then I'll conclude the course. Before going on to the scheduling, I also wanted to emphasize on creating more and more content like this. In case if you wanted to get notified, feel free to subscribe and also hit on bell icon. You'll be notified whenever we upload the content. Also leave comments about what further you wanted to learn, whether you wanted to learn performance tuning with respect to MongoDB, orchestrating pipelines using Airflow, or building REST APIs using Python-based frameworks such as Fast API, or anything related to cloud platforms such as AWS, Azure, GCP, etc., or any other thing with respect to MongoDB. Just add comment. I will review the details. If at all I can take care of it, I'll definitely take care of it. That being said, I hope you are enjoying the course so far. If yes, make sure to hit on like button. Also provide the feedback in comments, and also feel free to share with your friends. Building end-to-end pipeline including baseline load is done. However, there are few more touch-ups which we should take care of before planning for scheduling. First, let me exit from here. Once I exit, I wanted to go to app.py. Let me go to app.py. Now I am in app.py. If you look at this, I am actually hard coding the MongoDB connection details. We should not be hard coding like this, because if we hard code when we deploy in production where the database and the code are separated, this will not work. To ensure it work, we have to externalize the database connectivity information. On top of it, we also should have exceptions handled properly. Without proper exception handling, the pipelines are not reliable. I'll be handling two exceptions. One is related to database connectivity. The other one is related to REST API calls. First, let's make sure we select this. In this case, I'm selecting this entire code, and then I'm right clicking on it and then saying Copilot, then fix this. Now I should be able to send a prompt. The prompt will be, please add exception to this code. The exception should be related to Mongo connection. Now let me hit enter. Let's see what it have to say, then we'll take it forward. Now you see the details here. Automatically the exception is added. The entire code is enclosed in a try block. Also we have accept. In accept we have this message. Now we should be able to click on accept. You can see that exception handling is done with respect to this function called as load baseline data. In the similar fashion, you should be able to handle exceptions wherever we are attempting to connect to database. In this app.py, at least we have 6 different functions where we are attempting to connect to MongoDB database. I'll not be covering about adding exceptions to all the functions. I'll do it offline, but I'll show for a couple of additional examples. When it comes to this get pipeline checkpoint, you see it is returning result at the end. These have to be handled in a bit different way. When we use Copilot fix, it might generate the code or it might not generate the code. Don't worry if it doesn't generate the code. Just start with try here. Then make sure this piece of code is indented. Then you should be able to say accept here. You see it is auto-suggesting. You just have to hit tab to confirm. Then you see the code is generated automatically for us. Like this, I'll also take care of one more function. The function which I'll take care of is nothing but load weather data. In the similar fashion, let me add try here. Then let me indent this. Then let me say accept. Then let me add the code in the accept. This is how you should be able to take care of exception handling. On top of exception handling, I also wanted to externalize this. The way I can do it is like this. I can actually copy this. Now I can hit Ctrl F. You see we gone into find and replace mode. You can click on this to expand. Instead of this, I wanted to have this os.getEnv, then Mongo URL. If it is not set, then I wanted to use whatever is specified here. I should be able to paste here. Then close the single quote. I think I have to close the circular bracket also. In this case, I wanted to replace the string which is there as part of Mongo client everywhere. There are 7 of them. We have to replace in all 7. We should be able to replace in one shot. Now you see it is replaced in all 7 areas. This is how you should be able to externalize. To validate, all you need to do is you just open the terminal, then you just have to set a couple of environment variables. One is nothing but run flag. The second one is nothing but Mongo URL. If you don't set run flag, it will actually use daily. If you set it to baseline, it will clean up everything and run. When it comes to MongoDB URL also, if you don't set, it will use localhost. However, I'll be setting with this value only so that we confirm whether it works as per the expectations or not. Now, let me copy this. Let me go to the terminal. Let me say $env : Mongo underscore. It's not Mongo underscore. It is actually this one, Mongo underscore URL. The value should be whatever I have pasted. The key should be Mongo underscore URL. Then you have to have space, then equal to, then again space. Then we have to specify the URL in double quotes like this. If you are using Mac or Linux, you have to use export, then Mongo underscore URL. Without space, you have to specify the value in double quotes like this. And let me copy this. Then let me paste. This is how export command look like in Mac or Linux terminal. This is Windows. This might not work. Hence, I'll keep it like this. In case if you wanted to validate, you can always say $env : Mongo underscore URL. I think I have made some mistake. It have typed underscore many times. Let me say URL now. Now let me hit enter. You can see Mongo URL. Now I should be able to say Python app.py. In this case, when it comes to run flag, it will be else. It will be empty. Hence, it will get into else part and it will attempt to run for the next day. However, we have already caught up till T-2. Hence, it will not do anything. Let's wait until it is run. Then we will take it forward. You can see here, it is saying no new data to process, exiting the pipeline. You can always set the other environment variable, which is nothing but this one, run flag, then baseline. This time if I run, it should work without any issues. It will catch up for all the days starting from June 1st till T-2, which is nothing but 25th of June. While it is running, let me also take care of exception handling while invoking the REST API. The place where it is invoking REST API is nothing but this one, read weather data. Now let's copy this. Then let's right click, then say Copilot, fix this, update the code with relevant exception handling related to making REST API calls using request library. Let's see what it have to say. Now you see it have added the code. We just have to click on accept and then we can take it forward. If you wanted to test it, you can again run this to see if it is running as per the expectations or not. This is still running. As of now, it is processing data related to 2024 June 16th. Let's wait until it is fully run. Then we'll review the data in MongoDB. Then we'll take it forward. Now you can see it is successfully run. Let's go to MongoDB and then let's refresh this. Let's go to pipeline checkpoints first. You can see the data as per the expectations. You can also go to city weather hourly and get the number of records. You can see it have returned 150 records here or 150 documents. You can also look at pipeline run history. You can see the details here. This is how you should be able to take care of exception handling and also externalizing details with respect to connecting to the database. On top of using OS to load the external variables, when it comes to database connectivity information, we also dump all the properties like those into JSON file and then we'll use a JSON module to load and take it forward. That is also a standard approach. Also, we use properties files to take care of externalizing the connectivity information such as Mongo connection. All three practices are widely used, whether it is environment variables or external properties file or external JSON. There are quite a few other ways also, but these are quite common. As we got into details with respect to exception handling and also externalizing database connectivity information, now it is time for us to get into the details related to the scheduling. Once we are done with scheduling, we are almost done with the course. We will conclude the course with final notes. Yeah, we are done with the core logic related to our pipeline and also baseline load. Now it is time for us to understand the concepts behind scheduling. Keep in mind, I'll not be demonstrating how to schedule such kind of pipelines. I'll be deferring to other courses. For now, I'll just talk about what we typically do after coming up with a pipeline like this. Once the pipeline is developed, we need to schedule. First, let us understand what is scheduling. Scheduling is nothing but enabling the pipeline to run at regular intervals. We might schedule hourly or daily or even weekly or monthly. It all depends upon the pipeline which we have built. In this case, we wanted to run this every day for T-2. Hence, we should be able to schedule every day. Again, we have to decide on time. Typically, most of the batch jobs are scheduled during the off hours. It is primarily between 1 a.m. and 4 a.m. After 4 a.m., typically the pipelines related to reports will be run. The objective is to get reports ready by the time the executives or supervisors in the organization reach office. First, they'll schedule ETL jobs. Once the ETL jobs are run, then they'll take care of last mile ETL or reporting related jobs. That being said, now let us also talk about tools that we typically use when it comes to scheduling. The most basic tool is nothing but cron. Even in production, some of the companies schedule the jobs using cron. In many cases, they use simple cron directly. However, in most of the cases, they use scheduling or orchestration tools such as Airflow. Even tools like Airflow have cron-related features where you should be able to use cron syntax to define the schedules. Scheduling is very, very important. You need to make sure your pipelines are scheduled based on the requirements. That being said, on top of Airflow, we have other scheduling tools also. We have Control-M. We have scheduling tools within AWS such as EventBridge. Even Azure have its own scheduling tool. Almost all the cloud platforms have their own scheduling tools. There are n number of scheduling tools. Even all the ETL tools have the scheduling capabilities. When I say ETL tools, I'm talking about Informatica, Talend, etc. Yeah, we have gone through quite a few important details with respect to scheduling and tools. Now it is time for us to understand how typically the Python-based pipelines are integrated with scheduling tools. With the tools like Airflow, you can run Python code directly. You can use something called as Python operator. You can actually plug in this Python code directly into Airflow, and then you should be able to schedule. The other way is to use Docker and then use Docker operator to schedule. However, in at least 30 to 40% of the cases, instead of plugging in Python code directly, we use executable to schedule. When I say Python executable, I'm talking about wheel or egg file. We need to make sure we compile our Python code into wheel file or egg file. Then we can leverage that to integrate with the scheduling tool and schedule. When we build the egg or wheel file, which is nothing but Python executable, we need to make sure the required environment variables are set or the required properties are passed to the application in a specific way. Then we should be able to run the executable without any challenges. So building the wheel file or egg file and then scheduling is also very common approach. I hope you enjoyed the course so far. I hope you have practiced about how to build the pipelines using Copilot and also Copilot chat. Here we have built the pipeline using Python as programming language. The database which we have used is nothing but MongoDB. In case if you feel this course adds value to you, make sure to like and also to comment and also share with your friends. If you haven't subscribed to our channel yet, subscribe and also hit on bell icon so that you are notified whenever we publish the content. On top of this course, I also wanted to come up with additional courses around MongoDB. One is MongoDB Basics, where I talk about how to set up MongoDB, then perform CRUD operations, and also how to use tools like Mongo Compass, Mongo Shell, etc. to interact with MongoDB. Then other idea is about aggregation framework within MongoDB. I'll be taking a couple of use cases and I'll be walking you through the details with respect to aggregation framework within MongoDB. The third idea is nothing but building backend APIs using either Flask or Fast API. Flask and Fast API are nothing but backend frameworks within Python. I can cover using one of them. The fourth idea is about learning Airflow to orchestrate Python-based pipelines. As I discussed on these four ideas, I got one more idea. The idea is about performance testing and performance tuning around MongoDB. These are the 5 ideas I have in mind. If you have any other preference, feel free to comment. I'll respond and I'll take it forward. Even if you want to listen to all 5, feel free to comment. I'll try to come up with videos related to all 5. To get notified whenever we upload the content, you just have to subscribe to the channel and then hit on bell icon. You will get notified whenever we publish the content. That's it for now. Before we sign off, I wanted to hear the feedback from you. I wanted to know what you have learned in this course, whether it is Python or MongoDB or VS Code or Copilot along with Copilot chat or everything altogether. Also, you can talk about the end-to-end pipeline development. Whatever you have learned, don't forget to mention as part of the feedback. That being said, bye for now and catch up with you very soon.